Are you new to the programming world and haven't done any programming before? Or have you done some programming before, whether in Python or in some other programming language, but want to learn Python? If the answer is yes, then this video series is for you. What's up guys, my name is Puneet, I'm the co-founder of Programiz. I am also an Oracle certified Java professional and former Microsoft Most Valuable Professional. I'm delighted to be an instructor for this video series. In this series, I'll teach you everything you need to know to get started in programming with Python, step by step. Let's get started. Before we begin, let's answer an important question. Why learn Python? Why not Java, C, C++, or the dozens of programming languages out there? Let me answer this question first from the perspective of a programming beginner. Python is one of the easiest languages to learn because of its easy to use syntax. Take a look at this program to add two numbers written in Java. You don't need to understand it yet. Now let's see how we would write the same program in Python. As you can see, the Python code looks much more readable. The simplicity of Python syntax allows you to focus on the logic rather than focusing on syntax. That's the reason why Python is taught as the first programming language in many universities. Another reason to learn Python is because of its growing popularity and applications. Python is used in machine learning, web development, data analysis, scientific research, automation, and many more. Python is used by many companies such as Google, Facebook, Netflix, and so on. It is also used by thousands and thousands of small companies. So if you're looking for a job in programming, you'll find plenty of opportunities if you know Python. Now let's start learning Python, but before that, we need to be able to run Python. I'll use an online tool created by the Programiz team to run Python online for this series. Let me open my browser and I'll go to the URL that you can see on the screen. I've also posted the link in the description below. We will write Python in this text area, and when I hit run, it will execute that code. It's that easy. You can use the same tool if you want, or you can also use a beginner-friendly IDE like Thonny to run Python on your computer. I'll also provide a link to run Python on Thonny in the description below. Now that's out of the way, let's write our first Python program. We will create a program called Hello World. If you do not know, a Hello World is a simple program that displays Hello World on the screen. Since it's a very simple program, it is used to introduce a new programming language to beginners. Let's write the Hello World program. I'll type print, parenthesis, quotation marks, and Hello World, and when I press run, then Hello World is printed to the screen. Before ending this video, I have a pro tip for you. The only way you can learn programming is by writing code. I highly recommend you to write this program and run it on your own. If you have tried writing the program and got the output, give yourself a pat on the back because you have just created your first program in Python. If you haven't watched the previous video from this series, I highly recommend you watch that first. On my screen, I have the program from the last video. I'll go ahead and run it first. As you can see, Hello World is printed. This program is using the print function to print whatever is in between the parentheses. In this case, Hello World is a string. A string is simply a sequence of characters, either one or many, and is always wrapped inside quotation marks. Now let me take this up a notch and print another string. This time I'll use double quotes instead of single quotes. So I'll say print Python 3 is awesome, and this time when I press run, then as you can see, both Hello World and Python 3 is awesome are printed. Now you can use either single or double quotes for strings. They're basically the same. However, you cannot do something like this. So I'll change this to single quote, and when I press run, this time Python shows me an error. You cannot mix and match single and double quotes. So I'll change this back and make this double quote. When I press run, then you can see the same output as before. Another data type that's heavily used in Python is the numeric data, and there are two commonly used numeric data in Python, integers and floats. The difference between integer and float is that integer is a whole number and float is a decimal. We can use the print function to print integers and floats as well. Let me give you an example quickly. So I'll remove this old code and I'll say print 5, and I'll also write print 34.5. When you run the code, the integer 5 and 34.5 and the floating point number 34.5 are printed. One thing to remember is that if you use a number with quotations, it's technically a string. So if I surround 5 by quotes, 5 here is a string and not a number. I'll go back and remove these quotation marks for now. Till now, we learned about strings and numeric data and how to print them. In the real world scenarios, we may need to store and use this data in our program and not just print them. In order to store data and use them later in our program, we use something called variables. Before explaining more about variables, let me give you an example. So I'll remove the old code and I'll say city equals Kathmandu. Here I've created the variable city and this variable stores a string data Kathmandu. To store the data in a variable, we are using the equals operator. Now, instead of printing the string directly, I'll print the city variable and see what we'll get. So I'll say print city, and this time when I press run, then Kathmandu is printed to the screen again. This is because the city variable stores the string data Kathmandu. Now technically speaking, the city variable does not hold the Kathmandu string. When we write city equals Kathmandu, city is actually referring to the string Kathmandu. Now storing data and referring to the data may seem like similar concepts, but they are very different in Python. We will learn more about what referring actually means in detail in the future videos. For now, we will continue to say that city stores Kathmandu for simplicity. Now let me modify this program, and instead of city, I'll print city inside quotation marks and see what we get. So I'll say city, and this time when I press run, then instead of Kathmandu, the string city is printed. If I replace the quotes again and press run, then this time again Kathmandu is printed. We can also change the data a variable holds. After we print the city, let me change the city to New York and print it again. So I'll say city equals New York, and I'll say print city. Now this time when I press run, then it prints both Kathmandu and New York. Let's try to understand what's happening here. On line 1, when I say city equals Kathmandu, then city holds the string Kathmandu. On line 2, when I say print city, then since the current value of city is Kathmandu, that's what gets printed. On line 4, I change the value that the variable city is holding to New York. On line 5, when I print city, then since the current value of city is New York, that's what got printed on the screen. As you can see, we can change the value of a variable, which is why they are called variables. I hope that makes sense. It is also possible to assign a value of one variable to another. Let me give you an example. So I'll remove this code and I'll add another variable called destination underscore city equals New York. Now let me try something different. I'll say city equals destination underscore city. And when I print city, then you must have guessed by now, when I press run, then it prints New York, not Kathmandu. This is because the value of now city is now the value of destination city, which was New York. We can also assign numeric data to variables in a similar way we assign strings to variables. Let's take a look at it. So I'll remove this code and I'll say my favorite number equals 5. Now let me print this quickly. So I'll say my favorite number. I'll print that. Now let me create another variable called pi, and I'll say pi equals 3.14, and let me print pi. And now let me do the same thing I did before with strings. So I'll change my favorite number to pi, and then I'll print my favorite number. Now this time when I press run, then I get 5, 3.14 and 3.14 again. This is because on line 2, the value of 5, my favorite number was 5. On line 5, the value of pi was 3.14, and on line 8, when I print my favorite number, its value has been changed to the value of pi, which is 3.14. If we need to print more than one variable and data in a single print statement, we can separate them by commas. Let's take an example. So I can say print city, and I can put a comma here, and I can say Kathmandu. Here we are printing two strings, city and Kathmandu, in a single statement. One thing to notice here is that when we print objects separated by commas, Python adds a space in between them by default. So when I press run, then as you can see, it prints city and Kathmandu, but you can also see that there's a space in between which was not there here and here. We can also print variables and strings in a single statement. I'll show you an example. So I'll say city equals Kathmandu, and I can say something like print city, and instead of the string Kathmandu, I can do the variable city. When I press run, then I get the same output as before because the value of the variable city, which was Kathmandu, is replaced in the print. Let's try one last example. So I'll add another variable called KFC underscore locations, the value of which is 3, and then I can say print city, the variable city, and then KFC locations, comma KFC underscore locations. Here the city string, the city variable, the KFC location string, and the KFC underscore locations variable are printed in one print statement. I'll press run, and as you can see, all 4 are printed one by one and separated by space. That means the comma operator can be used to separate not just 2 but any number of objects, and Python will print them all. At this point, we have covered all the basics of variables. Before ending this video, let's talk about how to choose a good variable name. If you have noticed in our programs, we have used simple and descriptive variable names like city, KFC underscore locations, and destination underscore city. We can give variables like C instead of city. It works just fine. However, it is hard to understand what C means just by looking at the code. So I can replace city by C here and here as well, and I can run the program and I'll get the same output. But here you can see for yourself that it is very confusing to know what C really means. When we use good descriptive variable names, it becomes easier to understand the code. To make variable names descriptive, we may need to use names having more than one word. In that case, you can separate the variable name by an underscore like destination underscore city in our program. By the way, there are some rules you need to know while creating a variable. Rule number 1, you cannot create a variable name with space in between like this. You also cannot start a variable name with a number. Rule number 3, you cannot use certain words as a variable name. You cannot use else as a variable name because else is a keyword. These keywords have special meaning in Python and are part of the Python syntax. We will learn more about these keywords as we progress through the course. Before we end this video, here's a recap of what we learned. We learned about 3 most common data types in Python: strings, integers, and floats. A string is a textual data surrounded by quotes. Integers and floats are numeric data. Integers are whole numbers and floats are decimals. We also learned about variables. Variables allow us to store data so that we can use them later in the program. It's possible to change the value a variable can hold. And last but not the least, we learned to give good descriptive names to variables. By the way, you can find all the programs from this video on GitHub. I've provided the link in the description below. Feel free to copy the programs and edit them as you please. If you're enjoying this video, please also check out Programiz PRO, where we provide tutorials along with quizzes and challenges which will help you practice and test your learning in real time. Also, the course includes projects to give you an awesome experience of how programming works in the real world. And for our YouTube subscribers, we are giving 50% off on the yearly plan. Sign up by scanning this QR code or use the link in the video description to claim your discount. In the last video, we learned to create variables so that we can store data and use them later in the program. Let me give you an example quickly. So I'll go to my compiler and I'll say name equals Felix, and I can say print name. Now when I run the code, as expected, Felix is printed to the screen. Now if you're a skeptic like me, you must be thinking this is pretty useless, right? In the real world, we will typically ask the user what their name is instead of putting it ourselves. Let's see how we can do that. To take input from the user, we use Python's input function. So I'll replace this Felix by the input function, and this time when I press run, then Python waits for me to input something. Here I'll type Felix as before, and when I press enter, then I get Felix back. Let's try to understand what's happening here. When I pressed enter, then whatever I had typed, that is the string Felix, is stored in the variable name, and on line 2, when I print name, then the value of that variable name, which is Felix, is printed back. This program to take input from the user is working correctly. However, we haven't provided any clue to the user on what to enter. Let's change that. As we are trying to ask the user for their name, inside the input function, I will type enter name, and when I press run, then this time Python gives me a hint on what to enter. So I'll say Felix as before, and when I press enter, then this string Felix is stored in the name variable, and when I print the name variable, it gives me back Felix again. Now instead of a string, let's try to take a numeric input from the user this time. Let me modify this program. So I'll replace name by number, and obviously replace the variable names as well. And now when I press run, then this time I'll enter number 5. As expected, 5 is printed back to the screen. It's that easy, or is it? Well, the input function takes the input in the string form. When we enter 5, rather than the integer 5, the string 5 is stored in the number variable. We are getting 5 without quotations because the print function always hides the enclosing quotations when we print a string. We can know for sure it's a string rather than a number by using the type function. The type function returns the type of a variable. Inside the print function, I'll wrap the number variable by the type function. And this time when I press the run button, then it says enter a number, and when I press 5 and press enter, it says class str. Let's see what we get when we print the type of integers and floats. I'll remove this code for now, and I'll say number 1 equals 5. And here I'll say print type of number 1. Let me create another variable number 2, and this time I'll say 5.5, and I'll say print number 2. Now when I press run, then it says class int and class float. Here number 1 is an integer and number 2 is a floating point number. That is why when I run the code, you can see that we get class int first, which is representation of the type of number 1, and we get class float second, which represents the type of number 2, which is a floating point number. Let's get back to our original code of taking numeric input from the user. We still haven't solved the problem of taking integer and float input from the user. In fact, it's not possible to take integer and float input using the input function. However, what we can do is convert the string to a number after we take the input. In this code, after I take input from the user, I will add a line to convert the string to an integer. So here I'll say number equals integer number. And now when I press run, then it says enter a number. I'll enter something like 5, and it prints 5, but I have no way of knowing whether it is an integer or not. So here I'll wrap this number by type, and this time when I press run, it says enter a number. I enter 5, and it says class integer, which verifies that number indeed is now an integer. In our code, instead of adding this extra line to convert the string to an integer, you can also do something like this. So I'll remove this code, and I'll wrap this input function by the int function in the first line itself. Now when I press run, then as usual it says enter a number. I'll enter 5, and the class int verifies that indeed the number variable is now an integer. Here we're taking input from the user, converting it to an integer, and then storing it in the number variable all at once. We can also convert strings to floats. We use the float function for that. Let me change this code, and instead of integer, I'll use the float function. So here I'll replace the int function by the float function, and when I press run, then I can enter something like 5.5, and it says class float, which means this input was converted to a float, and that floating point number was stored in the number variable. When we pass values we have taken from the user to int and float functions, Python tries to convert the data to its corresponding integers and floats. In our programs, we have converted the string 5 to an integer and the string 5.5 to a float. These are numeric strings, numbers in string format. That's the reason it's possible to convert these strings to integers and floats. However, Python cannot convert every string to numbers. Let's find out what will happen if we try to convert a non-numeric string to a number. So here I have the same code from before, and this time I'll press run, and when it says enter a number, I'll enter a string like Felix. When I press run, then Python tells me that it could not convert string to float. Here Python tried to convert Felix to a floating point number, but obviously it couldn't, which makes kind of sense. There is no way for Python to know what's the equivalent floating point number for this Felix string. Before we end this video, here is a recap of what we learned. We use the input function to take input from the user. We can make the input function more descriptive by passing a string to it. The input function always takes the input in the string form, but we can convert a string to an integer using the int function. Similarly, we can convert a string to a float using the float function. If we try to convert non-numeric strings to integers and floats, we will get an error. By the way, you can find all the programs from this video on GitHub. I posted the link in the description below. Feel free to copy the programs and edit them as you please. Comments are hints that we can add to our program to make our code easier to understand. Let's take an example. I have this program to print a text entered by the user. To make this program a bit more readable, I can add a comment like this. So I'll say program to take the user's input. This line that starts with the hash symbol is a comment. We added this line with the sole purpose of making sure that anyone who reads our code understands what's going on. However, Python completely ignores them. We can also place comments after the code like this. So I can say take input, and then I can say print the name variable. Let me run this program. As you can see, it says enter a name, and I'll enter Felix. When I press enter, then it says your name is Felix. You must have noticed that only these two statements are executed, and even for these two statements, these lines are simply ignored. Now let me remove these two comments from my program. I'm removing them because these two statements are self-explanatory, and we do not want to make our code ugly by adding a lot of unnecessary comments. We can also use comments to debug our code. It is a common practice to comment out codes so that it is ignored rather than removing them completely. Let me give you an example. Let me write a program to take name and age input from the user. So I'll remove this whole code, and I'll say name equals input enter name, and then I'll say age equals input enter age. I want to convert it into an integer, and then I'll say print name is name, and I'll say print age is, and then age. Suppose in this program it was not required for us to take age input from the user. Instead of removing these two lines, what I can do is I can add a hash at the beginning of both of these lines so that they become comments and are ignored by the Python compiler or interpreter. Let me run this program. And as you can see, it says enter a name. I'll enter Felix. When I press enter, then it says name is Felix, but these two lines are completely ignored. Now later on, if I want to use the age variable again, or I need to accept that input from the user, all I need to do is remove these two hashes, and then they'll become statements instead of comments. A little pro tip for you: remember the keyboard shortcuts to apply comments. In most text editors, it's Control// if you're on a Windows and Command/ if you're on a Mac. This will be very useful in debugging our code. Python doesn't have multi-line comments like other programming languages such as C++ and Java. However, we can use the hash symbol at the beginning of each line to get the same effect. Suppose we have this code and we want to add comments to all three lines. We can do that by selecting all 3 lines and pressing Command/. Since I am on a Mac, as you can see, all 3 lines have been converted to comments. If I want these lines back, then I can again select them and press Command/, and they will be converted to regular Python print statements. You can also use multi-line strings as comments. If you do not know, we use triple quotes for multi-line strings like this. When I press run, our string is printed. Here we are assigning this multi-line string, I am a multi-line string, to the test variable, and we are printing that test variable. However, if we do not assign strings to any variable, it acts as a comment because Python completely ignores unassigned strings. For example, I can say something like, this program takes an integer input from the user and prints it. Then I can write out my program like number equals int input, enter an integer. Then, as we have been doing a lot in this video series, I will say print you entered number. Here this string acts as a comment because it is not assigned to any variable. Let me run this code. It says enter an integer, I will enter something like 7070, and it says you entered 70. As you must have noticed, these 3 lines are completely ignored by Python. Now let us take a moment to discuss why comments are important. Imagine you are working on a year-long machine learning project for a client. Since you were on a tight schedule, you decided to ignore comments. Anyways, you successfully delivered it to the client, and the client is happy about your work. Fast forward a couple of months, a new government policy was introduced, and the client wants the product to comply with that policy. Since you are the person who developed the app, it's your responsibility to maintain it. Without comments, you'll forget the reasons why you wrote a particular piece of code a certain way, and you'll end up spending a lot of time looking at your own code trying to understand it. Comments are even more important if you're working in a group. It makes it easier for other developers to understand and use your code. That being said, comments are not and should not be used as a substitute to explain poorly written code. You should always try to write clean, understandable code and then use comments as an addition. Before we end this video, here's a quick recap of what we learned. Comments are hints that we can add to our program to make our code easier to understand. Python completely ignores them. In Python, the hash symbol is used to write comments. Comments are also used for debugging code. Python doesn't have multi-line comments. However, you can use multi-line strings having triple quotes that act as multi-line comments. In programming, an operator is a symbol that is used to perform operations on values and variables. We've already used the equals operator in our previous videos. So we've been saying stuff like name equals Puneet. Here, the equals operator takes the value on the right and stores it in the variable on the left. We'll get back to more assignment operators in a second. Let's start with arithmetic operators first. We use arithmetic operators to perform arithmetic operations such as addition, subtraction, multiplication, etc. I'll copy a list of arithmetic operators here in my text editor so that it's a bit easy for us to use them. Let's try these operators one by one. I'll start with the plus operator. So I'll say something like x equals 5, and then I can say result equals x plus 10, and then I can print the result here. I'll run this code, and as you can see, 15 is printed. What's happening here is 10 and the value of x, which is 5, are being added by the addition operator, and the equals to operator is storing the result of these in the result variable. On line 12, when I print the result, because its value is 5 plus 10 or 15, that's what was printed. Instead of storing the result of adding 10 and x to the result variable, we can also directly print the result like this. So I can copy this and I can paste it here. I'll remove the result variable for now, and when I press run, I get the same result because the addition operator still takes the value of x and 10 and add them up, and that's what's get printed by the print function. But personally, I think using a variable to store the result looks a bit cleaner than this. So I'll revert back to the old code. We have learned to perform the addition operator at this point. Now let's try all these operators one by one. Let me change plus to minus and run this. As you can see, minus 5 is printed because 5 minus 10 is minus 5. In Python, we use the asterisk symbol for multiplication. So I'll replace this minus by asterisk, and when I press run, then 5 times 10, 50 is printed. Similarly, the forward slash is used for division. So I'll replace this asterisk by slash, and when I press run, then 5 divided by 10 or 0.5 is stored in the result variable, and that's what got printed here. The symbols of these four operators, addition, subtraction, multiplication and division, are similar to symbols in mathematics. Let's try 3 more arithmetic operators. The single asterisk is used for multiplication, but if we use 2 asterisks without any space in between, it's an exponent operator. So I'll replace this slash with 2 asterisks, and when I press run, I'll remove this 10 and I'll make it 2, and when I press run, then as you can see 25 is stored in the result because 5 raised to the power 2 or 5 times 5 is 25. The last 2 arithmetic operators are percent and 2 forward slashes. Using 2 forward slashes computes the quotient when one number is divided by another. Similarly, the percent symbol computes the remainder when one number is divided by another. Let me give you an example. So here I'll replace this result and I'll say quotient equals x double slash 2, and then I can say remainder equals x modulus 2. So the modulus, this sign when used to calculate the remainder is called modulus, and then I can say quotient is quotient and remainder is remainder. When I press run, then it says quotient is 2 and remainder is 1. That is because when 5 is divided by 2, the quotient is 2 obviously because 2 times 2 is 4, and the remainder 1 is stored in the remainder variable. At this point, we have covered everything we need to know about arithmetic operators when they are used with numbers. Before ending this section, I have a pro tip for you. If you use a lot of operators in a single statement like this, it's harder to understand which operation is performed first in this statement. To avoid this, we can use parentheses. So I can wrap these by parentheses like this, and now it's so much easier to understand. In the last section, we use the plus operator to add 2 numbers. The plus operator also serves another purpose in Python. It is used to join 2 strings. Let me give you an example. So I'll remove this old code and I'll say str1 equals hey, and I'll say str2 equals Jude, and then I can print the concatenation of hey and Jude like this. When I press run, then hey Jude is printed. It's working, but let me add a space between hey and Jude. For that, I can add a space at the end of hey, and when I press run, then as you can see there's a space now. We have already used the most common assignment operator equals, which is used to assign the value on the right to the variable on the left. In Python, you can also do something like this. So I can say x comma y equals 5 comma 6. Here 5 is assigned to the x variable and 6 is assigned to the y variable in one statement. So this code is equivalent to x equals 5, y equals 6. Personally, I feel this later syntax of x equals 5 and y equals to 6 is better because it makes the code easier to read. There are also some compound assignment operators in Python. These compound assignment operators combine arithmetic and assignment operators in one single place. I'll show you an example. So I'll remove this old code and I can say x equals 5 and I'll say x plus equals 10, and I'll also say x minus equals 10. This x plus equals 10 is equivalent to x equals to x plus 10. This plus equals to operator is called the addition assignment operator because it first performs the addition, then performs the assignment. Similarly, the x minus equal 10 is equivalent to x equals x minus 10. These compound assignment operators are available with all arithmetic operators. There are also other numerous operators in Python which we will learn about as we progress further in the video series. If you are curious, you can visit our website programiz.com for more information on Python operators along with numerous examples. The link will be in the description below. Let's put the things we have learned in this video in action. Suppose you're a university student and you need to pay $4,535 tuition fee for the next semester. The college is giving you a discount of 10% on early payment of your tuition fee. Since it's a very good offer, you decided to make an early payment. Now, can you find out how much money you have to pay? I'll store the fee in a variable called fee. So I'll say fee equals 4535. Now my discount percentage will also go in a variable called discount percent, and from here I can calculate the discount amount as discount percent by 100. I'll add parenthesis for more clarity, times the fee. This should be discount amount, and then I can say discounted underscore fee equals fee minus discount amount. Now let me print the discount amount. So I can say print fee after discount is discounted underscore fee, and when I press run, then I get the correct value of the fee after discount. Now it's time for you to solve a problem. Can you create a program to convert distance in kilometers to miles? Suppose you have a distance in kilometers stored in a variable like this. So I can say distance underscore km equals 564.5. You need to convert this distance to miles using the formula 1 kilometer equals 0.621371 miles. You will find the answer to this question in our GitHub repository. I'll also put this link in the description below. Before we end this video, here's a recap of what we learned today. The most common assignment operator is the equals operator. It is used to assign the value in the right to the variable on the left. We use arithmetic operators to perform basic arithmetic operations such as addition, subtraction, etc. If we use the plus operator with numbers, it adds two numbers. However, if you use the plus operator with strings, it joins two strings. If we use multiple operators in an expression, we can use parentheses to make our code readable. Before we learn to use comparison operators, we need to understand about Booleans. The Boolean is a logical data type that represents one of two values, either true or false. Let me give you an example quickly. So on my compiler screen, I'll say result1 equals true, and I'll say result2 equals false. Then I can print result1 and result2. Now here we have assigned a Boolean value true to result1 and a Boolean value false to result2. When we write true and false, the first letter is always capitalized. Also make sure that you don't wrap true and false around with quotes, otherwise they would be treated as strings. Now that we know about Booleans, let's learn about comparison operators. Python has a set of comparison operators that allow us to compare two values. If the comparison is correct, we get true, and if the comparison is wrong, we get false. Let me give you an example. Here, the less than symbol is a comparison operator that is comparing the number variable and the integer 10. Since the value stored in the number variable is 5, the expression number less than 10 is true, and when I press run, you can see that it indeed prints true. If you change number to 15, then the story is different. So here I'll say number equals 15, and when I press run this time, I get false because 15 less than 10 is obviously false. Printing these Boolean expressions like this has little to no use. In the next video, we will learn about the if statement that makes use of these Boolean expressions and which allows us to run different codes depending upon whether a Boolean expression is true or false. However, for the sake of this video, we will focus on comparison operators. Back to comparison operators, let me copy a list of all comparison operators in our text editor so that it's easier for us to use them. So here I'll remove the old code and I'll paste the comparison operators. We have already used the less than operator. Let's try these comparison operators one by one. I will start with the greater than operator. So here I'll say number equals 15 and I'll say print number greater than 10. When I run it, this gives true because number, which is 15, is obviously greater than 10 here. Now if I change the number to 10 and run this again, then this time I get false because 10 greater than 10 is false. Now let's see equal to and not equal to operators. The equal to operator gives true if two values are equal. So I can say number equals 10 and I can replace this and say number equals 10. So when I press run this time, I get true because 10 and 10 are equal. Comparing a floating point value and an integer value which are equal also gives us true. So here I can replace this by 10.0 and when I press run, I still get true. However, the comparison of integer 10 and a string 10 gives us false. So here let me replace this by the string 10 and then this time when I press run, I get false. The not equal to operator is the opposite of the equal to operator. If I change equal to not equal to here, then this time I'll get true because the string 10 is not equal to the integer 10. The last two comparison operators are less than or equal to and greater than or equal to. Let's try them in action. So I'll replace this code with 10 and then here I'll say number less than equals to 10. The expression number less than equals to 10 returns true if either number is less than 10 or equal to 10. It combines two operators less than and equal to into one. Now I'll run the code and it returns true because number is equal to 10 and that also counts. Similarly, there is also the greater than or equals to operator. So here I could have done greater than equal to and when I press run, this also works or this also returns true because of this equal to number equals 10 is true and that's why this is true. Now I could have changed this to something like 12 and this would still be true because number greater than 10 is true in that case. Python also has three logical operators and, or, and not. For your convenience, I have added here the list of all the logical operators and what they do. Let's start with the AND operator. I'll create three variables, age equals 22, GPA equals 3.8, and then I'll say a third variable result equals age greater than equals 18 and GPA greater than 3.6. Here the AND operator is telling me that the Boolean expression age greater than equals 18 and GPA greater than 3.6 both have to be true for this overall expression to be true. Now let me print the result here and when I press run, I get true. This is because both of these expressions are true. Now let me show you how the AND operation works by making the second condition false. So here I'll change this to 3.9 and when I press run, this time I get false. This is because, as I explained before, both of the expressions have to be true. The fact that the first expression is still true doesn't matter because the second expression is false and my result is now false. Now let's see the OR operator. I'll replace AND with OR in this code. This code means that if either this expression is true or this expression is true, the overall expression should be true. Now when I press run, I get true because although the second part of the expression is false, the age greater than equals 18 is true and that is enough for the whole expression to be true. Of course, both of these can be true and the result will always be true. So I can say 3.6 greater than 3.6, and when I press run, the overall expression is true because both of them are true. And the final logical operator is not. The not operator gives the complement of the result. For example, I'll replace all this code and I'll say result equals true and print result. This time when I press run, I get true, but I can do not result, and this time when I press run, then I get false. I can also do the reverse. I can say result equals false, and when I press run, I get true because this result was false. Now result could also have been a Boolean expression like age less than equals to 18, and then obviously I need an age variable 14. Now when I press run, then I get false because this expression is true and the not operator negates that result. We have covered all the basics of comparison and logical operators at this point. We'll be using these operators, especially comparison operators, extensively to create some interesting programs in the next few videos. Before we end this video, here's a task for you. Can you guess the output of this program? I'll give you a couple of seconds to pause the video and reflect on it. As always, you'll find the answer to the question in our GitHub repository. I've also included the link in the description below. Before we end this video, here's a recap of what we learned. The Boolean is a logical data type that represents one of two values, either true or false. The comparison operators are used to compare two values. If the comparison is right, we get true, and if the comparison is wrong, we get false. The logical operators are used on Booleans. There are three logical operators: and, or, and not. In Python, we use the if statement to create programs that can make decisions. Let's start with its syntax. So on my screen, you can see the syntax of the if statement. The if statement evaluates the test condition, which is a Boolean expression. If the test condition is true, the body of the if statement is executed. Otherwise, it is skipped from execution. Notice the spaces before the statement here. This indentation is used to differentiate between the body of the if statement. It doesn't matter how many spaces or tabs we use for indentation. However, we need to be consistent with it. Generally, it's considered a good practice to use 4 spaces for indentation. Now that we know the syntax of the if statement, let's try a working example. Suppose you're a university student and to pass the examination, you need to score 50 or more. If you score 50 or more, we will print you passed the examination. Let's see how we can implement this program. So first, I'll take the input from the user as score equals integer input, enter your score. Then I'll say if score greater than equals 50, print you have passed your exams. Let me add another print statement. I'll say print congratulations. Let me run this program, and here in the score I'll enter something like 75. As you can see, you have passed your exam and congratulations are printed to the screen. When your score is 75, as in this example, our test condition score greater than or equals 50 is true, and that is why these two statements are executed. Let me run this program again. This time, instead of 75, I'll enter something like 35. So this time, nothing is printed to the screen. This is because since score is 35, 35 greater than equals 50 is false, and the body of the if statement is skipped from execution. Our program is working correctly, but it's not printing anything when the score is less than 50. We might want to print something like, sorry, you failed your exam during this case. So I will add another if statement. I'll say if score less than 50, print sorry, you have failed your exam. And we can see that when I press run and enter 35, then it says sorry, you have failed your exam. This is because, again, this condition is false and this is skipped, but this condition is true and this code is executed. I have this code from our last section. I have removed the code that takes the user input and instead I have hard coded the value of score so that we can focus on the logic of the if statement. In this program, we have used two if statements to perform two different tasks. We know the student passed the exam if the score is greater than or equals 50. If the criteria is not met, we know the student failed the exam. In such cases, instead of writing the second if statement with a condition, we can use the else clause. Let's first look at the syntax of the if statement with the else clause. On your screen, you can see how it looks. What happens here is that if our test condition is true, these statements are executed, and if it's false, the statements inside the else clause are executed. Now getting back to our code to print whether the student passed or failed the exam. In this program, we know for sure that if the score is not greater than or equal to 50, then the student is failing the exam. So instead of writing the second if statement, we can replace the second if with else. So here I'll remove this if and I'll write else and a colon here. Let me read this code in plain English. If score is greater than or equal to 50, then print you have passed your exams and print congratulations. Else print sorry you have failed your exam. The else clause catches everything that's not covered in the ifs condition. Now when I run this code, you can see that sorry you have failed your exam is printed. The if statement with the else clause allows us to make a choice from two different options. But sometimes we need to make a choice from more than two options. In those cases, we can use the elif clause with a test condition. Let's see its syntax first. The if statement checks the condition inside the if statement or the test condition 1. If it is true, then this block of code is executed and statements 2 and statements 3 are skipped. However, if the first test condition is false, the control of the program jumps to the second test condition. If this test condition is true, its body is executed and other statements are skipped. If both test condition 1 and test condition 2 are false, finally the else body is executed. If necessary, we can add as many elif clauses as we want for our program to work, and among all those alternatives, only a single block of code is executed. Now we know how the elif clause works. Let's get back to our code to check whether the student passed or failed the exam. Here, this score variable stores the marks obtained by the student. So it shouldn't be greater than 100 or a negative number. If score is above 100, our test condition is true and you have passed our exam and congratulations is printed even though the score is invalid logically. And if score is a negative number, sorry you have failed your exam is printed because our test condition is false. Again, score shouldn't be less than 0. We need to fix this. We can fix this by adding a condition to check if the score is valid or not at the beginning. Only then we will check if the student passed or failed the exam. So in my code, I'll make the changes. Let's try for 105 and here I'll add a condition. I'll say if score greater than 100 or score less than 0, then print score is invalid, and then I'll turn this if into an elif, and now I have put that condition to check if the score is valid or not. Now if score is greater than 100 or score is less than 0, then score is invalid should be printed to the screen. As long as score is a valid number, our program should work correctly. Now if you remember, this OR is a logical operator which we discussed in the last video. This test condition is true if either this part or score greater than 100 is true or this part score less than 0 is true. As you can see, the syntax of the if statement is pretty simple. The harder part is the logic behind the test conditions, and you will get better at creating test conditions with practice. Also, be sure to check our video on comparison and logical operators that are used to create these test conditions. I posted the link in the description below. We have covered a lot of material in this video. It's time for you to practice what we learned. Here is one programming challenge for you to solve. Now, can you create a program to check whether a number is positive or negative or 0? To create this program, create a variable named number and assign a float value to it based on the user input. Then, using a if statement, check if the number variable is positive or negative or 0. If the number is positive, print the number is positive. If the number is negative, print the number is negative. And if the number is 0, print the number is 0. You will find the answer to this question in our GitHub repository. I posted the link in the description below. Since this video is already very long, we will not explore nested if-else in this video. If you're interested, you can find more information about the if statement in our website programiz.com along with numerous examples. I posted the link in the description below. Before I end this video, here's a recap of what we learned today. The if statement is used to create programs that can make decisions. The if statement evaluates a test condition. If the test condition is true, it executes the if body, but if the test condition is false, the if body is kept from execution. To specify the body of the if statement, we use indentation in Python. The if statement can have an optional else clause. The else clause is executed if the test condition is false. If you need to make a choice from more than two alternatives, you can add an optional elif clause with another test condition. If you're enjoying this video, please also check out Programiz PRO, where we provide tutorials along with quizzes and challenges which will help you practice and test your learning in real time. Also, the course includes projects to give you an awesome experience of how programming works in the real world. And for our YouTube subscribers, we are giving 50% off on the yearly plan. Sign up by scanning this QR code or use the link in the video description to claim your discount. Before we write the actual code of the while loop, let's take a look at its syntax. A while loop starts with the keyword while followed by a test condition followed by a colon. Then we write the body of the loop in the next lines. Notice the spaces before the body of the loop. This indentation is important as it indicates the body of the loop. Here's how this pseudocode works. Python checks this condition, which is a Boolean expression that evaluates to either true or false. If it's true, the body of the while loop is executed. At this point, it's similar to the if statement. However, unlike an if statement that checks the test condition only once, after executing the body of the loop, it checks the test condition again. This process goes on and on until the test condition evaluates to false. If the test condition is never false, the loop runs forever until the system's memory runs out. Let me give you an example. So I'll remove this old code and I'll say count equals 0. Then I'll say while count less than 5, print I am inside a loop. Let me add one more statement and say print looping is interesting. Let me run this program, and as you can see, these two print statements are executed again and again and again. Let's analyze what this program is doing. Here, count equals 0. In this line, count less than 5 or 0 less than 5 is true. That is why these two statements are executed. Now, since this is the while loop, it will again check the test condition. Again, count, or which is 0 less than 5 is true, and again these statements are executed. This happens again and again, and the condition count less than 5 is never false. So the loop runs forever. This is known as an infinite loop. However, most of the time, rather than running a loop forever and ever, we want loops to end at some point. Let's say we want this loop to run only 5 times. We can do that by adding one statement inside this loop so that this test condition count less than 5 is false after running 5 times. At the end of the loop, I'll add one statement count equals count plus 1. Here we have increased the count variable by 1 in each iteration of the loop. Now let's see from the start how the program works. Initially, the count variable is 0. That's why count less than 5 or 0 less than 5 is true and the body of the while loop is executed. If you've noticed, this new line that we have added is incrementing the value of count by 1. Since its initial value was 0, its new value is 1. Now the while loop checks the condition again. This time count less than 5 or 1 less than 5 is again true, and again the body of the loop is executed. But this time, since the value of count was 1, its new value is 2. Basically, this line count equals count plus 1 is increasing the value of count in each iteration of the loop from count equals 0 to count equals 4, which is 5 times. After the 5 runs, the count variable is increased from 4 to 5. Only then the test condition count less than 5 or 5 less than 5 is false. Let me press the run button and show you. So when I press the run button, this time I am inside a loop, and looping is interesting, is printed only 5 times. Let me change this program a bit. I will remove these two print statements and instead I'll print the count variable inside the for loop so that we can better understand what's happening. Now when I press the run button, as you can see, the value of count was 0 and it went up to 1, 2, 3, 4 and 5, and when count was 5, this condition was false and the loop exited. Now let me modify this program again. I will change count to 5 and I'll change this test condition to count less than equal to 10. Can you guess the output of this program without running it? I'll give you a couple of seconds to pause the video. You can find the answer to this program in our GitHub repository. The link will be in the video description. Now let's try one more example of the while loop. We will print the multiplication table of a number that is entered by the user from 1 to 10. To write this program, we need to create a loop that runs 10 times from 1 to 10. Let's do that first. So I'll remove this old code and I'll say number equals int, and then I'll take an input, enter a number, then I'll say count equals 1 while count less than equals 10, count equals count plus 1. Let me run this code and it says enter a number. When I enter 6, nothing really gets printed. This is because I have not printed anything inside the while loop. However, this program is still doing something useful. It is taking the variable count and increasing it from 1 to 10 in each iteration of the while loop because of the statement count equals count plus 1. Now, in each iteration of the loop, we need to print the row of the multiplication table. I will do that by adding a few lines. So here I'll say product equals number times count, and then I'll say print product. We have computed the product by multiplying number by count, and in line 6 we have printed the product by using the print statement. Let me run this program. When I run it, then it says enter a number, and when I enter something like 6, we can see that the output shows the result when 6 is multiplied by numbers from 1 to 10. Let's make that a bit more readable. Here, instead of print product, I'll say print number times count equals product. Let me press the run button and it says enter a number. I'll enter something like 6, and when I press enter, then it shows the multiplication table in nicely formatted manner. This is because, as we have seen in the previous video, the print function takes whatever is in between the commas and prints them with spaces in between. As you can see from this example, you can write pretty awesome programs using loops. The syntax of the while loop is pretty easy. However, the important part is the logic and how you use it. And how do you get good at logic? One word: practice. So here's a task for you to practice. Can you modify our multiplication table program so that you get a multiplication table from 10 to 1 instead of 1 to 10? You have to modify the same program that I've written here, and you can see the expected output on the screen. You'll find the answer to this question in our GitHub repository. Also visit our website programiz.com for more information on while loop with examples. I posted the links in the description below. By the way, if we know that our loop iterates for a certain number of times, like 5 times or 10 times in our examples, it's easier and better to use the for loop, which we will learn about in the next video. Before we wrap up this video, let's recap some of the concepts we have learned. Loops are used in programming to repeat a block of code. The while loop runs continuously until the test condition is false. If the test condition of the loop is never false, the loop runs infinitely until the memory is full. This is known as an infinite loop. Before we look at the working of the for loop, we need to understand about sequences. A sequence is a collection of items in an order. We have already used strings numerous times in our programs. A string is basically a sequence of characters. As you can see in the image, the string Python is a sequence of 7 characters P, Y, T, H, O and N. Let's look at another type of sequence. This sequence has 3 items separated by commas and enclosed in square brackets. This sequence is called a list. We will learn about these sequences in detail in the upcoming videos. For now, just remember that a sequence in Python is a collection of items in an order. Now that we know what sequences are, let's get back to our main topic, for loop. The for loop in Python is used to iterate over a sequence, and in each iteration we can access individual items of that sequence. For example, in my code editor, I'll show you. Suppose we have a string like this. Using a for loop, we can access individual items of this string Python one by one. Now I'll create a for loop. Here I'll say for character in text, then I'll print the character using our handy print function. When I press run, we can see that each character of the string Python is printed one by one. Let's see how this program works. During the first iteration of this for loop, the variable character will have the value P, which is the first letter in the text Python, and that will be printed to the screen. In the next iteration, the value of Y will be stored in the variable character, and when we print character, Y is printed to the screen. This goes on until we reach N, after which the for loop exits. By the way, we are seeing each character in a new line because the print function adds a new line at the end of each line by default. Before we move on, I'll add the syntax of the for loop here so that it's easier for me to explain it to you. For each item in sequence, execute the body of the loop. Now let's talk about looping through a list. Suppose we have a list of languages like this. Let's use the for loop to iterate through each item of this list one by one. Just like we did in the strings example, I'll say for language in languages print language. Now when I press run, as you can see, all 3 languages are printed one by one. Let me read out this code in plain English. For each language in the languages list, store that language in the language variable and print it. Now let's move on to Python range function. If you watched the last video of the while loop, we used it to repeat a block of code a certain number of times, like 5 times and 10 times. Let me give you an example. I'll create a while loop that iterates 5 times from count equal to 1 to count equal to 5. I'll remove the old code and I'll say count equals 1, and then I'll say while count less than equals 5, print count, and then I'll increase the value of count like count equals count plus 1. I'll press run, and as expected, the numbers from 1 to 5 are printed. There's an easier way to write this same program using the for loop. For that, we'll use the range function. Let me give you an example. I'll comment out this old code, and then I'll say for count in range 1 to 6, print count. This range function creates a sequence of numbers from 1 to 5. It doesn't include the last value 6. Let me run this code, and as expected, it prints 1 to 5. Range is a very useful function. We will learn more about the range function in detail in a future video, so be sure to subscribe and hit the bell icon so that you don't miss that video. Let's try one more example of the for loop. We will print a multiplication table of a number entered by the user from 1 to 10. Let's first take input from the user. So I'll say number equals integer, input, enter, and integer. Since we want to print the multiplication table from 1 to 10, I will create a loop that iterates 10 times from count equal 1 to 10. So here I'll say for count in range 1, 11. As we have discussed before, 11 will be excluded and this will give me a sequence from 1 to 10. Now we need to find the product by multiplying number by count inside the body of the loop. So here I'll say product equals number times count. Now let me use the print function with commas to format the output nicely. So I'll say print number comma x or times count equals product. When I run it, it asks me to enter a number and I'll say something like 9, and when I press enter, as you can see, the multiplication table is printed in this nice format. Here count is increased from 1 to 10 and we have calculated the product by multiplying number and count. So in the first iteration, product will be 9 times 1, which is 9. In the second iteration, product will be 9 times 2 and so on. Before we end this video, here's a programming task for you. Can you create a program to find the sum of numbers from 1 to 100? Basically, the result should be equal to result equals 1 plus 2 plus 3 plus blah 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 plus 100. If you're a programming beginner, you might find this program a touch harder. Give it a try. You can always find the answer to this program in our GitHub repository if you get stuck. I will provide the link in the description below. Before we end this video, let me recap the concepts that we have learned. Loops are used in programming to repeat a block of code. A for loop is used to iterate through items of a sequence. If you know that a loop needs to run for a certain number of times, like 5 times or 10 times, it is better to use the for loop instead of the while loop. Range is a useful function that creates a sequence of numbers. It's common to use range in a for loop to iterate the loop a certain number of times. In the last 2 videos, we learned how to repeat a block of code using loops. The while loop repeats a block of code until the specified test condition is false, and the for loop repeats a block of code until the last item in a sequence is reached. Sometimes we may need to end the loop without checking the test condition or skip execution of code inside the loop. In such cases, break and continue statements are used. I'll create a loop to print numbers from 1 to 5 to get started. So I'll say for item in range 1 to 6 and I'll print item, and as you can see, when I press run, then 1 to 5 is printed. Now let me add a break statement here. This time when I press run, then only 1 is printed. Let's try to figure out what's happening here. In the first iteration, the item value is 1, 1 is printed, and then the break statement is encountered. As soon as we encounter the break statement, we exit the loop. Now let me try something interesting. I'll move this break statement before the print statement, and this time when I press run, absolutely nothing gets printed because the loop never reaches this print item statement. The break statements are almost always used inside decision making statements like if and else, because most of the time we may want to end the loop only when a certain condition is met. Let me show you this with a practical example. I'll remove this code and I'll say if item equals 3, then break, otherwise print item, and I also want to find out when the loop is exited, so I'll print outside the loop the end. Here we have a condition to break this loop when item is equal to 3. Now when the item becomes 3, the if condition is true and the break statement terminates the loop. That's why 3, 4 and 5 will not be printed this time. Let me run this code to show you this. So when I run this code, then 1 and 2 are printed and the end is printed. Let's create one more example of the break statement. We will use a while loop to take a number input from the user. If the user enters a positive number or 0, we will print the number and again take another numeric input. However, if the user enters a negative number, we will use the break statement and end the loop. To approach this program first, we will create a while loop with a test condition that's always true. Inside the loop, we will take input from the user. So I'll remove this old code and I'll say while true, and I'll say number equals float input, enter a number. Now this is an infinite while loop. The only way to end this loop is by using the break statement. Now let's write our condition to print the number if it is positive and break the loop if it's negative. So here I'll say if number less than 0, then break, otherwise print you entered, and here I'll print the number. When I run this program, then it says enter a number. Let me enter a positive number like 4, and it says you entered 4.0, and let me enter another positive number 67. It says you entered 67. Now let me try entering a number that's negative, so I'll say -9, and when I press enter, then it exited me from the loop and the program as well. Let's talk about the continue statement in Python now. The continue statement in Python skips the rest of the code inside the loop for that iteration. The loop will not terminate but continues on with the next iteration. Let me explain this with the help of an example. So I'll remove this old code and I'll say for I in range 5, and then I'll say number equals float input, enter a number. Then I'll print the number. This program asks me for 5 numbers, so I'll say 1, 2, 54, 34, -76, and something like 67. Then it exited after 5 iterations. What if you only want to print the positive numbers entered by the user and skip the printing of the negative numbers? In such cases, we can use the continue statement to skip code inside the loop if the user enters a negative number. So here I'll add the continue statement like this. I'll add the condition to check if the number is negative and continue the program without printing here. So I'll say if number less than 0, continue. This time when I run the program, then it asks me for an input, I'll say 34. It asks me for another input, I'll say 56.5 or 7, and it prints the number. And now if I enter a number like negative number like -87, then it does not print the number. It asks me for another number immediately. This is because when this condition is true, the continue statement takes me to the next iteration of the loop. Let me continue adding positive numbers. So I'll say 23, and then I'll add another negative number like -54. And as you can see, this whole loop still executed for 5 times, but depending on whether I input a negative number or a positive number, I was able to use the continue statement to either print the number or go directly to the next iteration. Before we end this video, here's a little programming task for you. Suppose we have a list like this. Can you create a program so that all items of the languages list are printed except Swift and C++? You can find the answer to this question in our GitHub repository. Also visit our website programiz.com for more tutorials and examples. I've posted the link to both the GitHub repository and our website in the description below. Let's recap the concepts we learned in this video. The break statement terminates the loop immediately when it is encountered. The continue statement skips the code after it when it is encountered. Most of the time, we want to change the way loops work only when a certain condition is met. That's why we usually use break and continue inside the decision-making statements like if and else. Suppose you need to create a loop or a decision-making statement. However, we are not sure yet what its body will be. In such scenarios, we can use the pass statement. Let me give you an example. So I'll say number equals 5.5, and then I'll say if number greater than 0.0, and then I'll add a pass statement here. When I run this program, my code will run without any errors. Now I can write code after the if statement and run it and implement the statement when it's necessary. What would happen if we used comments instead of the pass statement in the above program? Let's find out. So I'll remove this pass and I'll say to do will figure out later. Now this time if I press run, then Python gives me an error. It says unexpected EOF while parsing. This error is basically saying you cannot end the program file like this. Something is wrong. We are getting this error because the body of the if statement is empty and comments don't count because Python completely ignores comments. So whenever you need to create loops, if-else statement, functions and classes with an empty body, you can temporarily use the pass statement. Before I end this video, let me recap the concept that we learned. In Python, pass is a null statement that does nothing. The pass statement can be used to create loops, if-else, statement, functions and classes with an empty body. You will learn about classes and functions in the next few videos. In programming, a function is a group of related statements that performs a specific task. They help us divide a large program into smaller chunks so that it's easier to understand and change. Suppose you need to create a program that draws circles and rectangles of different colors based on user input. Instead of creating one big chunk of statements to create this program, we can create 3 functions to solve this. First, create a circle function, then a rectangle function, and then the color the shape function. This helps us to divide complexity and we can focus on only a small part of the problem at one time. Now let's see how we can create a function in Python. To create a function, we use the def keyword, which stands for the function definition, followed by the function name. Then I'll use the empty parenthesis followed by a colon. So I'll say def greet empty parenthesis and colon. Here we have defined a function named greet. However, this code will give us an error because the function body is missing. Let's fix that. For now, I'll only add 2 print statements as its body. So I'll say print hello, and then let me add another print statement, print how do you do. Remember, we need to use indentation to specify that this is the body of the function. We have successfully created a function named greet. Now let me run this code. And we don't really see anything. This is because defining a function won't do anything in itself. To bring the function into action, we need to call it. Our function name is greet with empty parentheses. So to call it, I will just use greet with empty parentheses. So here I'll say greet, and now when I press run, then you can see that hello and how do you do are printed. Here's how this code works. When we call the function, the control of the program jumps to the function header. Then the statements inside the function are executed. When this task is completed, the control of the program goes back to the function call and the next statement after the function call is executed. One thing with functions is that once we define a function, we can call it any number of times. Let's call our greet function 3 times. So here I'll say greet and one more greet. And now if I press run, as you can see, the function has run 3 times. That's why these 2 statements were executed 1, 2, and 3 times. So if we need to perform a task again and again, we can wrap the codes inside a function and use the function any number of times. We just need to call the function again and again. One thing to remember when we create a function is that we need to define a function first before we can call it. This code, for instance, will not work. Let me run this code to show you. Here, when the greet function is called, Python doesn't know that this function exists because it's defined after the function call. So always remember to define a function before you use it. Now let's talk about Python arguments and how our greet function from the previous example can be changed to allow arguments. Suppose we want to make our greet function a bit more personal. So instead of printing hello, we want to print something like hello Jack or whatever the person's name is. In such cases, we can pass values to a function. These values we pass to a function are called arguments. So I'll go back to the code that I started with. I'll remove these two greet functions because I want only one. And here, inside the greet function, I'll pass the jack string like this. This value that we pass during a function call is called an argument. So jack here is an argument. And in the function definition, I'll add a variable in the greet function. I'll call it name. This name variable accepts whatever value is sent as an argument during the function call. In this case, jack is transferred to the variable name. Now I can use the name parameter inside the function. So now I can say hello, comma, name, and when I press run, then I get hello Jack. Let's see step by step how this function works. When we call the greet function with the argument Jack, then this is passed to the name variable inside the function definition. Then the statements inside the function are executed. We can use the name parameter inside the body of the function. When this task is completed, the control of the program comes back to the place from where the function was called, and the next statement is executed. In this case, there's nothing here. It's also possible to pass multiple arguments to a function as per our needs. If we need to pass multiple arguments to a function, we can separate them by commas. Let's see this in action by creating a function to add two numbers. So I'll remove the old code and I'll create a new function called add numbers. So I'll say def add underscore numbers. Obviously I'll need two parameters, n1 and n2, and then inside the function I'll say result equals n1 plus n2, print the sum is, and here I'll say result. Now outside the function I'll say number 1 equals 5.4, number 2 equals 6.7, and then I can call add underscore numbers, number 1 comma number 2. In this program we have passed number 1 and number 2 as arguments to the add numbers function. These arguments will be accepted as n1 and n2 once they are passed to the add numbers function. So inside the function n1 will be 5.4 and n2 will be 6.7. Then we have added the numbers and printed them inside the function itself. Let's run this code and see the output. As you can see, I now have the sum of those two numbers. In our program to add two numbers, we are finding the sum of numbers and printing it. It's working fine. However, it's better just to find the sum inside the function and print the result somewhere else. We can achieve that by using the return statement. Inside the function, I'll remove this print statement and I'll say return result. When we return a value, it comes back to the function and we can assign this return value to a variable like this. So here I can say result equals add numbers number 1 comma number 2, and I can print the result as print the sum is, and then I can say result. Let's see step by step how this program works. We call the add numbers function with two arguments, number 1 and number 2, which are accepted by the function definition as n1 and n2. The sum of n1 and n2 is calculated and the result is returned to the function call. This returned value is assigned to the result variable, and in the next line we just print the result variable outside the add numbers function. Whenever a return statement is encountered inside a function, the control of the program goes back to the place from where it's called. Let's see an example of this. Let's get back to our greet function that we wrote before. I'm pasting it here. When I press run, then we get hello Jack, and how do you do here? Now let me modify this program a little bit. I'll add a return statement after this line and let's see what happens. Now when I press run, then you can see that only hello Jack is printed. This is because when the return statement is encountered, immediately the function terminates and control of the program goes back to the place from where the function is called. At this point, we have covered all the basics to create a function. These functions we created ourselves are known as user-defined functions. Actually, we have already used functions numerous times in all of our videos. Remember print? It is also a function. The function definition of this print statement is defined somewhere inside the Python programming language. That's why we can just call the function and it just works. These functions defined inside of Python are called built-in functions. We have also used other built-in functions like float, int, input and so on in our videos. There are numerous built-in functions available in Python that make our life a whole lot easier. For example, suppose we have a list like this. Now if we need to find the length of this list, we can use the len function. So here I can say length equals len marks, and I can print the length of the list as print length is comma length. Let's run this code and see the output. When I press run, then as you can see it says length is 5, which is the length or the number of items in this marks list. If we instead needed to find the sum of the items of the list, we don't need to manually write the code ourselves. We can use the sum function that's available in Python. So here I can say marks underscore sum equals sum of marks, and then I can print the sum as print the total marks you got is, and then I can say marks underscore sum. Now when I press run, then it says the length is 5 and the total marks you got is 308, which is the sum of these marks. If you're interested, you can find all the built-in functions available in Python in the programiz.com website. The link will be in the description below. Let's put all the things we have learned in this video in action. Suppose you have just attended a university examination. The marks you obtained in various subjects are stored in a list like this. You want to find the average marks you obtained in the exam, and based on the average marks, you want to find your grade. The grading rule is like this. You'll get grade A if the average marks is equal to or above 80. You'll get grade B if the average marks is equal to or above 60 and less than 80. You'll get grade C if the average marks is equal to or above 50 and less than 60, and if the average marks is less than 50, you will get grade F. To solve this problem, we will create two functions, one to find the average marks and another to compute the grade. So let's get started. I'll start with the function definition, but before that let me add a little comment. I'll say function to find average marks. Now let me define my function as def find average marks. Now the argument to this will be a list of marks, and inside I'll say sum of marks equals sum marks. I also need to find the number of subjects or the number of marks I have, so I'll say total underscore subjects equals the length of this marks list, and then now I can calculate the average as average underscore marks equals sum of marks divided by total subjects. Let me return this average marks variable, and now outside the function I can say average marks equals find average marks. I'll pass in the marks list, and here I'll say print your average marks is, and I'll say average underscore marks. When I press the run button, I can see that my average marks is 67.8, which is the average of these 5 numbers, which is calculated as sum of these numbers divided by the total number of subjects, which is 5 in this case. Now we need to create another function to calculate the grade based on the average marks. Let's do that now. I'll create another function, but before that let me add a little comment. I'll say calculate the grade and return it, and then I'll say def compute underscore grade. Now the parameter or the argument to this will be the average marks, so I'll say average marks, and inside I'll say if average marks greater than equals 80, then grade is A, elif average marks greater equals 60, then the grade is B. If average marks greater than equals 50, in this case the grade is C, and the else clause I'll say grade equals F, and outside the if block I'll say return grade. Now I can use this compute grade function as grade equals compute underscore grade average marks. Now let me print this grade as your grade is and the grade variable. Now when I press run, I can see that my average marks is 67.8 and my grade is B, which is not the best result, but at least I now know what my grade is. Before we end this video, here's a programming task for you. Can you create a program to add and multiply two numbers? For this, create two functions, add underscore numbers and multiply underscore numbers. These functions should compute the result and return them to the function call, and the results should be printed from outside the function. You'll find the answer to this question in our GitHub repository. Also visit our website programiz.com for more tutorials and examples. The links will be in the description below. Now let's recap what we learned. A function is a block of code that performs a specific task. We use the def keyword to define a function. To bring the function into action, we need to call the function. We can call the same function as many times as we want as per our needs. We can pass values to a function. These values passed to functions are called arguments or parameters. The return statement can be used inside a function. The return statement returns a value from a function and exits the function as well.
If you're enjoying this video, please also check out Programiz PRO, where we provide tutorials along with quizzes and challenges which will help you practice and test your learning in real time. Also, the course includes projects to give you an awesome experience of how programming works in the real world. And for our YouTube subscribers, we are giving 50% off on the yearly plan. Sign up by scanning this QR code or use the link in the video description to claim your discount.
I have this program to add two numbers from the last video. Here we have called the add underscore numbers function with two arguments. Then our function adds those two numbers and returns the sum. These arguments we pass to the function are called positional arguments because the first argument 5.4 is assigned to the first parameter n1 and the second parameter 6.7 is assigned to the second parameter n2. These arguments are passed based on their position. Now let me modify this program and remove this 6.7 from the function call. Can you guess what will happen? Let me run this code. As you can see, we get an error, type error, add underscore numbers missing one required positional argument n2. This error message is telling us that we need to pass a second argument during the function call because our add underscore numbers function takes two arguments n1 and n2. In such cases, we can provide default values to parameters in the function definition, which we will see next. I still have this program from the last example which gave us an error. It was because there is one argument in the function call but two arguments in the function definition. To fix this issue, either we can add a second parameter in the function call or we can provide a default value to the parameters. Let me provide default values to parameters in this program. So I'll say n1 equals 100 and I'll say n2 equals 1000. Now I have given 100 as the default value to n1 and 1000 as the default value to n2. Let me run the program again. This time when I ran the program, the output was 1005.4. What's happening here? Well, what's happened here is we have provided 5.4 as an argument. This value will be passed to n1. However, we haven't provided the second argument, so the default value of n2 equals 1000 will be used, and the sum of 5.4 and 1000 is 1005.4. Let me modify this program again, and this time I won't pass any arguments. So I'll remove 5.4, and in this case the default values of n1 and n2 will be used, as we are not passing any values. Let me run this code, and as you can see, we are getting 1100, which is the sum of the default values 100 and 1000. In Python, we cannot only pass arguments to a function based on position, but we can also pass arguments by name. Let me give you an example. Here we are passing Jack to the name parameter and what's going on to the message parameter. These are positional arguments. Now let me call this function again, but this time I will pass arguments by name. So I'll say greet message equals howdy, and I'll say name equals Jill. During this second function call, we have specified the arguments by name. So howdy is passed to the message parameter and Jill is passed to the name parameter. The order of the arguments doesn't matter here because we are using name to specify which argument is passed where. These arguments are called keyword arguments. There are a couple of things we haven't mentioned about arguments in this video for simplicity. If you're interested to learn more about arguments, visit our website programiz.com. I posted the link in the description below. Now let me recap the concepts we learned in this video. When we pass arguments to a function without specifying the name, the arguments in the function call is assigned to parameters in the function definition based on the position. That means that the first argument is assigned to the first parameter and the second argument is assigned to the second parameter and so on. These are called positional arguments. You can also give names to arguments during a function call. These arguments are called keyword arguments. The order of arguments doesn't matter when we use keyword arguments. We can provide default values to parameters in the function definition. These values will be used if we do not pass arguments during the function call. I have this function to add two numbers on my screen. This add_numbers function takes two parameters, finds their sum and prints the result all in the same function. Now instead of printing result from inside the function, let's see what will happen if we print result after the function call. So I'll cut this code and paste it after the function call, and this time when I run this code, then it gives me an error. It says result not defined. What Python is trying to tell us is that the result variable is not defined on line 6. What's going on here? This is where the concept of local variables comes in. Any variable that is created inside a function is local to it, meaning the result variable is local to the add numbers function. When this function ends, this variable gets destroyed. If you remember, we can fix this by using a return statement. So I can say return result, and here I can say output equals add numbers, and here I can print the output. With the return statement, we are not using the local variable directly, rather we are returning its value to the function call. This concept of a local variable is a good thing because anyone using the add numbers function doesn't have to know what's inside it. They just need to know what arguments to pass and what value it returns, and they can use this function without a problem. This makes our code reusable to not only us but also to our fellow programmers. Any variables that are created outside a function are called global variables, and you can use these global variables from both inside and outside of a function. Let me give you an example. So I'll create a global variable called message, and I'll say message equals how you doing, and now let me create a function def greet that prints this message, and I'll call this greet function. Here message is a global variable as it's defined outside the scope of the function greet, and you can use it anywhere after it is defined. Let me run this code to show you this. So when I press run, then it says how you doing. Now let's see what will happen if we define a variable with the same name message inside the function. So I'll say message equals how are you, and here to know that I'm printing the message from inside the function, I'll say inside message inside function, and after greet I'll again print message
message outside function, and I'll print the message variable here.
Here I'm trying to see what the value of message is by printing it from both inside and outside the function.
When I press run, then you can see message inside function is how are you, and message outside function is how you doing.
Inside the function, when we update the message variable, then rather than changing the global variable message, a new local variable called message is created. That message has a new value called how are you, and that is what gets printed here. After the greet function, since the global variable message is unchanged, when we print it from outside, then it shows the global value. If we need to change the global variable inside the function, we can achieve this by using the global keyword. So here I'll add a new line that says global message, and this time when I press run, then you can see that from inside the function the value is how are you, but because I had defined it as global, the actual global message got changed, and when I come out of the function and try to print message again, the outside message or the global message variable has been changed to how are you. Before we end this video, here's a tip for you that will serve you well in the long run. Try to avoid the use of global keyword inside a function whenever possible. It makes our code really hard to understand, as you must have seen in the last example. Now let's recap the concept that we learned in this video. A variable defined inside a function is local to it. When the function ends, this variable is destroyed. Variables defined outside a function are called global variables in Python. Inside functions, the global keyword can be used to change the value of a variable to a global scope. However, it's considered a bad practice and you should try to avoid it. Let's learn how to create a list. We'll start with the list data type. In Python, a list is a sequence of items in an order. We create lists by placing items inside square brackets separated by commas. Now it's not necessary for a list to have all of the items of the same type like this. We can also create a list having mixed data types, and it may also contain duplicate elements. Let me show you. So here I'll say mixed list, and then I can say random list equals something like 2.5. Let me add in a string called hello and say a negative integer like -5, and I can also repeat a number like 2.5. This list that I've stored in the random list variable has 4 items: a float, a string, an integer, and again the same float. We can also create lists that do not have any items like this. So here I can say empty list, and I can say list1 equals just the square brackets without any items in between, and let me print it out to see what I get. Now when I press run, then I can see that numbers list is printed having 4 elements, and the list1 is an empty list that's printed here. Since there are no items inside list1, it's an empty list. The size of an empty list is 0. To check it, we can use the built-in len function. Let me remove the mixed list first, and then I'll wrap the numbers list and the empty list list1 to see what I get. Now when I press run, then I get 4 and 0, which are the lengths of the numbers list and list1 respectively. Now let's learn how to access list elements. A list is a sequence and its items are always in order. Suppose we have a list of programming languages like this. So I'll say languages equals Python, JavaScript, C++, and Kotlin. Now let me print the languages here. I'll say print languages, and when I press run, then you can see that Python, JavaScript, C++, and Kotlin are printed. So the first item in this languages list is Python. The second language is JavaScript, the third one is C++, and the last one and the fourth one is Kotlin. We can access individual items of list by using something called index,
and it starts from 0. So the index of the first item is 0, of the second item is 1, of the third item is 2, and so on. Now suppose we want to get this first item Python. To get this item, after the name of the list, I will type square brackets. And inside those square brackets, I'll put 0 because I want to access the first element. Now when I run it, then I get Python. Similarly, to get C++, we need to use index 2 because it's the third element of the list. So I'll replace 0 by 2 because I want the third element, and when I press run, then this time I get C++. This languages list we have been working with has 4 items. Can you guess what will happen if we try to access the 5th item using 4 as an index? Why don't we try it in our code and see it for ourselves? So I'll change index 2 to 4, and now when I press run, then Python tells me list index out of range. This error message means that we are using an index that does not exist because the 5th item doesn't exist. Now let's talk about negative indexing. In Python, we can also use negative indexing for sequences like lists. Using a negative index gives us items from the last. So -1 gives us the last item, -2 gives us the second last item, and so on. I have this languages list we have been working with on the screen. Let me change index to -1 and run it. So here I'll say -1, and when I press run, then I get Kotlin, which is the last item in the list. Similarly, we can get JavaScript using -3 because it is the third element from the last. Now when I press run, then I get JavaScript this time. As you can see, negative indexing is pretty useful when we need to access items from the last because we do not even need to know the size of the list. Now let's learn about slicing of a list. We learned to access an individual item from a list in the last 2 sections. It's also possible to access a whole section of items from the list, not just a single item. Let me give you an example. I have the same code that we have been working with on my screen. I'll remove the -3 index to access the third last item. Now let me access the first 3 items from the list. So I'll use 0:3. Let me run this code. This time I get the first 3 items of the list on the screen. If you've been following along, that means the items having index 0, 1 and 2 were printed. The thing you need to remember with slicing is that the first index is inclusive and the last index is exclusive. So 0:3, that means 0:3 will give me 0, 1 and 2 index, which are the first 3 elements of the list. Now let's try to get the second, third and fourth items. Since the starting index is inclusive, we need to use index 1 to get the second item. And the end index is exclusive, so we need to use 4 as the end index. Using 4 will give us items up to the index 3, which is technically the 4th item. I'll press run, and as expected, the second, third and fourth elements are printed to the screen. Let me tell you an interesting fact. If we use the empty start index, the slicing starts from the beginning of the list. So here I'll try something like :3, and when I press run, then I get the first 3 elements. This means that just leaving the first element open or empty is equivalent to putting 0 in front. So when I press run, I get the same result as before. Similarly, if we use the empty end index, the slicing ends at the last index. So here I'll remove this and I'll say I want to start from 1 and I don't know and I want to go to the end. So when I press run, then the slicing starts from the 1 index and it goes up to the end of the list. That means Kotlin should be included in the slice. By the way, we can also use negative indexes during slicing. If you're interested, you can check out our website programiz.com to find more information about it. Now let's learn how to change items of a list. Lists in Python are pretty dynamic. It's super easy to add, modify and delete items of a list. The term we use for these kinds of changeable objects is mutable. So we can say that lists are mutable objects.
Let's see how we can change items of a list. I'll start with the same programming languages list we have been working with. Now let me change the second element from JavaScript to Ruby. It's pretty easy in Python to do that. We just need to assign Ruby to the second element like this. So here I'll say languages 1 equals Ruby, and after this if I print languages and press run, then now I can see that the second element, which was JavaScript, has now been changed to Ruby. If you don't know, then Ruby is a popular programming language. We can also change a portion of the list in a single statement. I'll modify the code I had written where I changed JavaScript to Ruby. But this time, I will change the second and third item of the list in one go. Here, I'll say languages 1 colon 3 equals list of Ruby and Dart. Now when I press run, here I have accessed the second and third items, which are JavaScript and C++, using the slicing operator colon, and then modified them by putting the new values Ruby and Dart in their place. That is why the elements that were present in index 1 and 2 are now Ruby and Dart. Now let's learn about iterating through a list. Before we learn to iterate through a list, let's learn about the in keyword. The in keyword is used to check whether an item is in the list or not. I have this languages list from before. Now let me check if Python is in the list or not. Here I can say print Python in languages. The Python in languages statement prints true because Python is in the languages list. Let me run this code. Now the Python in languages statement prints true because Python is indeed in the languages list. Let me change Python to Rust and run the code. So here I'll say Rust in languages, and when I press run, this time I get false because Rust is not in the languages list. This can be helpful when we want to check whether an item is present in a list or not. We can use this as a test condition in an if statement for decision making. We can perform one set of tasks if an item is in the list and another set of tasks if the item is not in the list. If you want to get individual items of a list one by one, the easiest way to get them is by using a for loop. We have already discussed them in the previous videos, but let me revise it again here. I'll remove the print statement and I'll add a loop. So I'll say for language in languages, and then I'll say print language. This for loop iterates through elements of the list one by one until the end of the list is reached. I'll press run, and as you can see, all 4 programming languages are printed here one by one. This language variable is Python in the first iteration, JavaScript in the second iteration, and so on. And that is what we have printed inside the body of the loop. If you want to learn more about the for loop in detail, check out our Python for loop video. The link will be in the description below. Now let's learn about list methods. The reason lists are so versatile is because it's so easy to add, change, and remove elements from it. Suppose we have the same languages list we have been working on in this video. Now let's say we want to add an item to the list. We can use the append method to do this. This method is already available when we work with lists. Let's say we want to add Rust to our list. We can just say languages.append Rust. So I'll remove this old code and I'll say languages.append Rust, and now if I print languages and press run, then you can see Rust is also included in the languages list. Let's say instead of adding Rust in the end, we want to insert it in the second position. We can use the insert method for that. So I'll replace this append and I'll say insert, and because I want to insert it in the second position, that means the index 1. And when I press run, then now I can see that the Rust programming language has been appended in the second position, which is the index 1. Now let's learn how to remove items from a list by removing C++ from our list using the remove method. So I can just say languages.remove C++, and now when I press run, then I can see that C++ has been removed from the list. Sometimes you might have to create a copy of a list.
To copy a list, we can use the list copy method. So here I'll remove this old code and I'll say languages1 equals languages dot copy, and instead of languages, if I print languages1, then I can see that I get the same programming languages list that I had before. The languages.copy returns a new list and it is assigned to the languages1 variable. There are many more list methods readily available for use that make working with lists very easy. You can find all the list methods and how they work with examples in our website programiz.com. I will also include the link to the list methods page of our website in the video description. Now that we have covered lists, let's talk about tuples or tuples as some people like to call them. A tuple in Python is similar to a list. It's also an ordered collection of items. The only difference between the two is that lists are mutable, that is, we can change elements of a list, whereas tuples or tuples are immutables. We cannot change the tuples elements. To create a tuple, we need to wrap items inside parentheses, and these items should be separated by commas. So let me create a new tuple. I'll say numbers equals parentheses 21 minus 5, 6 and 9, and then I'll print the tuples as print numbers. Let me quickly run this and you can see that the tuple is printed. We can access elements from a tuple in a similar way we access elements from a list. Accessing elements from a tuple is possible as long as we do not try to change the value. So here I'll say new numbers 2, and when I press run, then I get the element in the second index or the third element. We can also perform slicing similar to lists. So here I can say 1 colon 4, and when I press run, then I get elements from index 1 to index 3, which is the fourth element. Like in a list, the first index is inclusive and the last index is exclusive. We can also loop through a tuple using a loop. So here I'll remove this old code and I'll say for number in numbers, and I can say print number. Now when I press run, then I get all the numbers. All the things that we have learned till now about tuples is similar to that of lists. Now let's see how tuples are different from lists. As we have mentioned, the difference between tuple and list is that a list can be changed, but tuple cannot be changed. Let's see that in action. I have this tuple that contains the same programming languages from before. Let's try to change its first element from Python to Java. So here I'll say languages 0 equals Java. Let me also print the languages. Here I'm trying to assign Java to the first element. Let me run this code. We get an error, type error, tuple object does not support item assignment. This error message is telling us that we are trying to change an item of a tuple by assigning it a new value, but it's not allowed with tuples. We also cannot add and remove items from a tuple because unlike lists, tuple doesn't have methods like append, insert and remove. So if we are sure that our sequence won't change till the end of the program, it's better to use tuples instead of lists. If you're interested, you can find more information about tuples and tuple methods on our website programiz.com. I'll include links to some relevant articles in the video description. Before we end this video, here's a little task for you. Can you guess the output of this program that you see on your screen? I'll give you a couple of seconds to pause the video. As always, you'll find the answer to this question in our GitHub repository. I'll also include this link in the description below. We have covered a lot in this video. Let's have a quick recap of what we learned. A list is a collection of ordered items. To access individual items of a list, we use indices. Python indexing starts at 0. There is also a concept of negative indexing in Python. This is used to access elements from the last. We can access a portion of a list by using the slicing operator colon. We can use loops to iterate through items of a list. Python has several useful methods that make it easier to add, change, insert and remove list elements. Finally, we learned about tuples. A tuple is similar to a list except tuples are immutable. We cannot change elements of a tuple.
In Python, we create strings by enclosing characters inside quotations like this. This hello there inside single quotations is a string. We have assigned it to a variable named text. And in the next line, we have printed the text variable. When I run it, as expected, hello there is printed. Instead of single quotes, we can also use double quotes like this. So I can say text equals double quote, hello there, and then double quote again. When I run it, again hello there is printed. However, we can't use mismatching quotations like this. So I cannot say single quotation, hello there, double quotation. If I press run, then Python tells me that there is an error. We can also use triple single quotes or triple double quotes to create a string like this. So I can say text equals double quote, double quote, double quote, hello there, and then again three double quotes in the end. Now when I press run, I get hello there like before. This is usually used for creating a string that spans multiple lines. Let me add another line inside triple quotation marks. So here I'll say hello there, how are you doing? Now when I press run, then I get hello there, how are you doing on separate lines. Now suppose we want to create a string like this. He said, what's there? This string contains both single quotes and double quotes. I'll run this code, and as you can see, we get an error. This is because Python thinks this part inside quotation marks is the string, and whatever is outside of that or following that is regular Python code. To fix this, we can escape characters like quotations by using a backslash before it. So here I can say, he said backslash what's there. And now when I press run, then I get the correct output. Now that we know how we can create strings in Python, let's see how we can access characters from a string. As mentioned before, a string is a sequence of characters, and these characters are in order. So we can access individual characters of a string using indices, just like with lists and tuples. Suppose we have a string like this. The index of the first character p is 0, the index of the second character y is 1, the index of the third character t is 2, and so on. Let's access the first character p from the string. To access the first character, after the name of the string, we need to type square brackets, and inside it, I will provide the index. Since we are trying to get the first character, we need to use index 0. So here I'll say print text square bracket 0, and when I press run, then I get p, which is the first character in the string. Now let's try to get the fourth character from the string. To get this character, we need to use index 3 inside square brackets. So here instead of 0, I'll say 3, and when I press run, then I get h, which is the fourth character in Python string. Python also supports negative indexing for all sequences, including strings. Using a negative index makes it easier to access characters from the last. The index of the last character in the string is -1, the index of the second last character is -2, and so on. Let's try negative indexing in action. I have this program from our last example on my screen. Let me change the index to -1. So I'll say print text -1, and now when I press run, then as you can see, n, which is the last character in the string, is printed. We can not only access a single character, but we can also access a substring from the string using the slicing operator. To get a portion of the string inside the square brackets, I'll mention the start index, colon, then the end index. So here I'll say give me text 1, 4. Let me run the code. Here I get yth. The thing you need to remember with slicing is that the first index is inclusive, but the last index is exclusive. That's why we got only yth and not o, which is the fourth index. Now let me remove the start index from our code. When I run it, we get characters from start to the third index. This is equivalent to saying text 04. When I run it, I get the same output. Similarly, if we do not mention the end index, we get a string containing characters from the start index to the last character. Here I'll say give me all the characters from the second index up to the last, and when I press run, then I get thon. That means start from the second index, which is t, and go till the end. Strings in Python are immutable and we cannot add or change characters of a string. Let's see what happens when we try to change characters of a string. Suppose I have the same text string we have been working with. I'll try to modify the first character by saying text 0 equals small p, and then let me try to print text. Here when I press run, then Python tells me there's a type error, str object does not support item assignment. This error message is telling us that we are trying to change characters of a string, but it's not allowed. However, we can perform operations on strings without modifying the original string, which we will see next. Strings are one of the most frequently used data types and we can perform various operations on them. Before we learn about different string methods, let's see a couple of operations that we can perform with strings. The first operation is string concatenation. It means the joining of two strings into one. To join two strings, we can use the plus operator. Let me give you an example. So here I'll say text1 equals Python and text2 equals programming. Now I can say result equals text1 plus text2, and let me print the result. Here we have created a new string by joining text1 and text2, which is assigned to the result variable. The important thing to note here is that we are not modifying Python and we are not modifying programming. We are actually creating a new string which is stored in the result variable. Let me run it, and as you can see, a new string called Python programming is created and printed. Let me add a space between Python and programming so that it looks a bit better. So here I'll say text1 plus space plus text2, and now when I press run, then you can see that there's a space in between. We can also repeat a string a certain number of times very easily in Python. We use the asterisk operator for that. So here I'll go back to my old code that says text equals Python, and then I can say new underscore text equals text asterisk 3. Now when I print new underscore text and run the code, then you can see Python 3 times is printed. Python also has several string methods for common string tasks, but before we check that, let's see how we can iterate through a string. The easiest way to iterate through characters of a string is by using a for loop. Let's take an example. I'll go back to my old code that says text equals Python, then I'll say for character in text, and inside the for loop I'll say print character. When I run this code, then you can see that each character is printed one by one. This for loop iterates from the starting character p to the end character n. In the first iteration, the character variable holds p, in the second iteration it holds y, in the third iteration it holds t, and so on. And in each iteration we have printed the character variable. This loop iterates 6 times because the size of the string Python is 6. We can check this by using the len built-in function. It returns the length of any object in Python. So here I'll say print len text, and now when I press run, then you can see that 6 is printed. It's also pretty easy to check if a string is inside a string or not. Let me quickly give you an example. So I'll delete this whole code and then I'll say print p in text. Now when I press run, then since p is present in the word Python, I get true. Let's try something more interesting. So instead of p, I'll say yth, and when I press run, then this time also I get true because yth is inside Python. Now let me try something else. I'll say ont, and when I press run, this time I get false because ont is not inside Python in that order. As I have mentioned before, strings are probably the most frequently used data type. To make working with strings easier, Python has numerous string methods readily available for us to use.
let's try some of the string methods now. Suppose I have a string like this, I like Python 3. Let's say we want all characters in this string to be lowercase. Now to do this, we can use the lower method. So here I can say result equals text dot lower, and in the next line I'll say print result. Now when I press run, then you can see I like Python 3 with all characters in lowercase is stored in the result variable and printed. Similarly, if you want all uppercase characters, we can use the upper method. So I'll replace lower with upper, and when I press run, then I get I like Python 3 in uppercase. Now suppose we want to find the index of this Python substring, then we can use either find or index method. I'll change this upper to find, and inside it I'll mention what substring I want to find. So here I'll say Python, and now when I press run, I get 7 because 7 is the index of the first occurrence of Python inside this string. Let's try one last example. Suppose we want to replace Python 3 with Java. We can do that by using the replace method. I'll use the replace method instead of find, and inside it I need to pass two arguments. The first argument is the substring we want to replace, so I'll put Python 3. So here I'll say text.replace and then Python 3, and in the second argument, since we want to replace it with Java, I'll put Java. This code returns a new string with Python 3 replaced with Java. I'll run the code, and as you can see, I like Java is printed. There are numerous other useful string methods in Python. You can find all the string methods, their descriptions and working examples in our website programiz.com. The link is in the video description. Before we end this video, here's a little task for you. Can you guess the output of this program? I'll give you a couple of seconds to pause the video. As always, you'll find the answer to this question in our GitHub repository. I'll also include this link in the description below. We've covered a lot in this video. Let's have a quick recap of what we learned. A string is a sequence of characters. To create a string, we use either single quotes or double quotes or triple quotes. We can access the specified character from the string by using its index. We can also get a substring from a string by using the slice notation. Since a string is a sequence, we can iterate through characters of a string using a loop. And finally, we learned about different string methods.
If you're enjoying this video, please also check out Programiz PRO, where we provide tutorials along with quizzes and challenges which will help you practice and test your learning in real time. Also, the course includes projects to give you an awesome experience of how programming works in the real world. And for our YouTube subscribers, we are giving 50% off on the yearly plan. Sign up by scanning this QR code or use the link in the video description to claim your discount.
A dictionary is a collection of key value pairs. It is similar to associative arrays in other programming languages. To create a dictionary in Python, we need to put these key value pairs inside curly braces separated by commas like this. This dictionary has two items separated by commas, and each item is a key value pair separated by a colon. For the first item, its key is name and its value is Linus. Similarly, for the second item, its key is age and its value is 21. Let me print this dictionary and run it. So here I'll say print person1, and when I press run, then the same dictionary is printed. There are a couple of things we need to remember when we create dictionaries. First, keys of a dictionary can be any immutable object like numbers, strings, and tuples. However, they cannot be objects that can be modified like lists. Second, the keys must be unique for identification. Let me change the name key to 10 and this age key to a tuple and run it. So here I'll say, instead of name, I'll say 10, and I'll turn this age into a tuple. And now when I press run, then as expected, this is a valid dictionary. This works because both these keys, 10 and this tuple age, are immutable objects. Dictionaries are optimized to get values when the key is known. If you remember, we used numbered indices like 0, 1, and 2 to get elements from sequences like lists and tuples. In the case of dictionaries, these keys are used as indices. I have this program from our last example. Suppose we want to get Linus from this dictionary. To get this, I'll type square brackets after our dictionary name, and inside I'll type the name of the key, which is name, and now when I press run, I get Linus. Similarly, to get 21, we need to use age as a key. So here, instead of name, if I type age and press run, then this time I get 21. Now let's see what happens if we try to access a key that's not in the dictionary. I'll change this age to hobbies, and when I press run, then Python tells me that there's a key error because hobbies is not present in this dictionary person1. Sometimes instead of getting this error, we may just want to know if the key exists or not and decide what to do based on it. In that case, we can use the dictionaries get method like this. So here I can say person1 dot get, and inside parenthesis I can say hobbies. Let me run this code. This time, instead of an error, we get none. This none object means empty or no value. This can be useful because I can use this in an if statement and run different codes based on it. We can also pass a second argument to the get method. If the key doesn't exist, this default value is returned instead of none. I'll provide a list as a default value. So here I can say person1.get hobbies, and inside let me pass a list saying dancing and fishing. Now when I press run, now instead of none, we get this list back. I have this person1 dictionary we have been working on in my screen. Now let's change the name to Dennis. To do so, we need to assign a new value to the key like this. So here I'll say person1 name equals Dennis. I'll run it, and we can see the value of the name key is now Dennis. If we try to assign a value to a key that doesn't exist yet, it will add a new item to the dictionary. Let me show you. So here I'll say person1 hobbies equals dancing and fishing. I'll press run, and as you can see, a new key hobbies has been added, and its equivalent value dancing and fishing has also been added to this dictionary. To remove an item from the dictionary, we can use the dictionaries pop method. Let's see how we can remove this item from the dictionary. To remove the item, we need to pass the key of the item in the pop method like this. So here I'll say person1.pop name. Now when I press run, then you can see that name Linus has been removed from the dictionary. This pop method also returns the value of the removed item. So if I wrap this code inside a print function and press run, then I get Linus, which was the removed item. There are many of these dictionary methods readily available for us to use. This makes working with dictionaries much easier. You can find all the dictionary methods and how they work along with examples in our website programiz.com. I'll include the link in the video description. Similar to sequences, we can easily iterate through items of a dictionary by using a for loop. And in each iteration of the loop, we get a key of the dictionary. Let's see that in action. I have this same dictionary we've been working with. So here I'll say for key in person1, and here I'll say print key. Now when I press run, then as you can see, name and age, which are the keys of the dictionary, are printed. When we know these keys, we can easily get the corresponding values as well. Let me add a line to print values of the dictionary in each iteration of the loop. So in the next line, I'll say print person1 key. Now when I press run, then as you can see, name Linus, age 21 is printed, which are the keys and the corresponding values in this dictionary. Starting from Python 3.7, the order of items in a dictionary is preserved. So when we iterate through a dictionary, we get the keys in the order in which they are in the dictionary. At this point, we have pretty much covered the basics of Python dictionaries. Before we end this video, here's a task for you. Can you guess the output of this program? I'll give you a couple of seconds to pause the video. As always, you'll find the answer to this question in our GitHub repository. I'll also include this link in the description below. Here's a recap of what we learned in this video. A dictionary is a compound data type that allows us to work with key value pairs. We can easily access a value from a dictionary if its key is known. To add or change items from a dictionary, we can assign values to the keys. We can remove items from a dictionary by using the pop method. And finally, we learned to iterate through keys of a dictionary using a for loop. A set is a collection of items like lists and tuples. However, there are some important differences between them. Sets in Python are like sets in mathematics. A set cannot contain duplicate items, and these items are not in any particular order. Also, we can only use immutable objects in set like strings, numbers, and tuples. So a set cannot have mutable objects like lists and dictionaries. Just 3 things to remember when we imagine sets in Python. Number 1, items of a set are not in any particular order. Number 2, no duplicate items are allowed. And the third one, items must be immutable objects. Now that we know what sets are, let's see how we can create them. To create a set, we place items inside curly brackets separated by commas like this. So here I'll say animals equals curly bracket, and then I'll add the list of animals as dog, cat, tiger, and elephant. Let me print this set and run it. So I'll say print animals. When I press run, then you can see the set was printed, but you must have noticed that this order of animals is different from this order. This is what I meant when I said that the items of a set are not in any particular order. This is also the reason why set items also don't have indexes. Now let's see what happens if we try to create a set having duplicate items. Inside this set animals, I will repeat the dog string twice. So here I'll add another dog at the end, and now if I press run, then you can see that in the output dog is printed only once, even though in the set definition dog is repeated twice. The duplicate dog was removed from the set because sets in Python automatically remove all duplicate items. It's also possible to create a set that doesn't have any items. To create an empty set, we need to use the set function. Now we cannot use empty curly braces for this because it would create an empty dictionary instead. So here I'll remove this old code and I'll say animals equals set, and then I'll print animals. Animals. Now when I press run, you can see that an empty set has been printed. The set function that you see here can also be used to create non-empty sets. I'll show you an example. So here I'll add a list inside this set function. I'll say cat, dog, tiger, and elephant. Here we have passed a list inside the set function. The set function converts this list into a set. When I press run, then you can see that this list has been converted to a set because it has curly braces instead of square braces. Here I have passed a list of 4 animals, cat, dog, tiger, and elephant, and the set function has converted it into a set. That is why the order has been changed. We can convert other iterables like tuples, dictionaries, and strings into a set in a similar way. Now let's see how we can add items to a set. Sets in Python are mutable. We can add and remove items from them. To add a single item to a set, we use the add method. I have this animal set we have been working on in this video. Let me add monkey to it. To add it, after the set's name, I will type dot, so animals dot, and then I'll say add, and inside the parenthesis I will pass the monkey string. Now let me print the animals set so that I can verify if monkey was added correctly or not. So I'll say print animals, and now when I press run, then you can see that monkey was also added to the set. We can also add all the elements of iterables like list, tuples, and other sets to a set. For that, we can use the update method. Let's take an example.
Suppose we have a set and a list like this. Now we want to add all the items of this wild animals list to this animals set. We can do that by using the update method like this. So I can say animals.update wild animals. Now I'll print animals and see what I get. When I press run, you can see that leopard and tiger were added to animals list. One thing to note here is that elephant is common in both animals and wild animals. Since sets cannot have duplicates, the output has only one elephant. By the way, we can also pass multiple iterables to the update method like this. So here, along with wild animals, I'll also add a set containing dolphins. When I press run, then as you can see, dolphins was also added to the set of animals. The update function added items from both wild animals and the set containing dolphins to the animal set. Let's now learn how to remove items from a set. To remove an item in a set, we can either use the discard method or the remove method. Let's use the discard method first. I have this set of animals. Now I'll use the discard method as animals.discard. Let me discard the cat, and now let me print animals to see what I get. When I press run, you can see that dog, elephant and tiger are still in the set, but cat has been removed. Now instead of discard, let me try and use the remove method. So here I'll say remove, and when I press run, I get the same output, of course in jumbled order. Both discard and remove are used to remove an item from a set. However, there is an important difference between them. If the item we are trying to remove is not in the set, discard returns none, whereas the remove method throws an error. Let me change cat to something like ferret here. So I'll say animals.remove ferret, and when I press run, then Python says there is a key error. Now when I use discard and run it, you can see that no error was thrown. We do not get any errors and our animal set is printed. What happened here is that this code returned none because ferret is not in the animal set. However, we haven't assigned the return value to anything. Then this print statement prints the animal set. By the way, we can also remove all items in a set at once by using the clear method like this. So here I'll remove this code and I'll say animals.clear, and when I press run, then you can see that animals is now an empty set. Let's see how we can find if an item is in the set or not. Similar to other compound data types, we can check if an item is in a set or not by using the in keyword. Let's see an example. So here I'll remove this old code and I'll say print tiger in animals. When I press run, then I get true because indeed tiger is present in the set of animals. If we change tiger to something like ferret and run it, so I'll say ferret, when I press run, then this time I get false because ferret is not present in the set of animals. It is also possible to loop through items of a set like other compound data types. Let's see an example. Here I have the same old set from before. I'll remove this code and I'll say for animal in animals print animal. When I press run, then you must have guessed the output by now. All the animals are printed one by one. However, the order in which these items are printed is random. Let's take a look at Python set operations now. As I mentioned before, the way sets work in Python is similar to how sets work in mathematics. In this video, we will cover two set operations, union and intersection. Suppose we have two sets, domestic animals and wild animals like this. The union of these two sets is a set of all items in both domestic animals and wild animals. To find the union of sets, we can either use the union method or use the pipe symbol. Let's see an example. So here on my compiler, I'll remove the old code and I'll say domestic animals equals dog, cat and elephant, and then I'll say wild animals equals lion, tiger and of course elephant again. Now I can create the union of these sets by saying animals equals domestic underscore animals dot union wild underscore animals. Let me print the animals variable now. I'll say print animals. When I press run, then I get a set containing animals from both the domestic animal set and the wild animal set. The order of sets doesn't matter. Here I can reverse this order and I can say wild underscore animals dot union domestic underscore animals, and when I press run I get the same output. As I mentioned before, we can also use the pipe symbol to find the union. So here I could have also written wild animals pipe domestic animals, and when I press run I get the same output. Now let's talk about intersection of sets. Suppose we have two sets, domestic animals and wild animals like before. The intersection of these two sets is a set of items that are common in both domestic animals and wild animals. To find the intersection of sets, we can either use the intersection method or use the ampersand operator. Let's see an example. So I have the same set of domestic animals and wild animals from before, and here instead of saying union I'll say wild animals dot intersection domestic animals. Now when I press run, then I get a set containing elephant, because elephant is the common element between domestic animals and wild animals. Now let's use the ampersand operator to find the intersection this time. I'll say wild animals ampersand domestic animals, and when I press run I get the same output as before. You can find more information about different set operations and methods in our website programiz.com. I'll include the link in the description below. At this point we have covered all the basics of Python sets. Before we end this video, here's a task for you. Can you guess the output of this program? I'll give you a couple of seconds to pause the video. As always, you'll find the answer to this question in our GitHub repository. I'll also include the link in the description below. Now let's recap what we learned in this video. A set is a collection of unordered items. Since the items do not have any order, they also do not have any indexes. A set also cannot contain duplicate items, and all items of a set must be immutable. Although the items of a set need to be mutable, sets themselves are mutable, and we can add and remove items from a set. Sets in Python are similar to sets in mathematics. That's why we can perform operations like union and intersection of sets.
Suppose we want a sequence of numbers from 1 to 10. To get this sequence, we can use the range function like this. So I can say result equals range 1, 11. Here the start of the sequence is inclusive but the end is exclusive. That's why it gives us a sequence from 1 up to 10 and not 1 up to 11. Let me print the result. So I'll say print result, and when I press run, instead of getting the result, the sequence 1 to 10, I get range 1, 11, which is basically the same thing I've typed here. So what's happening? Well, the range function returns a range object, which is a sequence of characters. We can see what's inside this object by converting it to some other type like a list. So here I'll convert the result to a list like this by using the list function, and now when I press run, then I get the sequence I was asking for, that is 1 to 10. One thing to notice here is that by default the step between the numbers 1, 2, 3, 4, 5 and up to 10 is 1. We can change this step, as you will see later in this video. Since range generates a sequence of numbers
it is commonly used in for loops to iterate the loop a certain number of times. Let me give you an example. So here I'll remove this old code and I'll say for value in range 1, 6, and then I'll say print value iteration. Here this range gives us a sequence from 1, which is included, to 5 because 6 is not included. Now when I press run, then it says 1 iteration, 2 iteration, it goes up to 5. As we can see, the loop iterates 5 times from value equal to 1 to value equals 5. In our examples up to now, we have passed 2 parameters to the range function: start, which is the start of the sequence, and stop, at which the sequence stops. It's also possible to use range without passing the start parameter. If the start parameter is not passed, 0 is used as the default value. Let me give you an example. So here I'll say result equals range 11, and then I'll say print list result. Now when I press run, then it gives me a value from 0 to 10, because it's the same as saying give me a range from 0 to 11, and when I press run, it essentially gives me the same result. This makes it even easier to use range function in a for loop. Suppose I want to iterate a loop 5 times. I can simply pass 5 to the range function like this. So I'll remove this old code and I'll say for value in range 5 and print value. This loop iterates 5 times from the value 0 to the value equals 4. When I press run, then you can see it says 0 to 4. If you have noticed in our examples, the gap between 2 consecutive numbers is 1. Let me show you again. So I'll remove this old code and I'll say result equals list range 1, 11. And when I print this, as expected, it says 1 to 10. As we can see, the difference between the numbers is 1. This is because by default, step of 1 is used. This code is equivalent to adding 1 as the third parameter, which is the step that we want to use. This range function basically means start from this number, go up to this number, not including it, and use 1 as the stepping number. Let me change the step to 3 and see what happens. So here I'll replace this 1 with 3, and when I press run, then this time the difference between 2 consecutive items of this sequence is 3. We can also use negative numbers in the range function like this. So I'll remove this old code and I'll say result equals list range 5 to -6, and the step will be -1. Now when I print the result and press run, then you can see that it started from the number 5, it went up to -6 but not including -6, and the difference between 2 consecutive list items is -1. By the way, range only works for integers. We cannot use floating point numbers inside the range function. At this point, we have covered all the basics of Python's range function. Before we end this video, here's a task for you. Can you create a list like this using the range function? I'll give you a couple of seconds to pause the video here. As always, you'll find the answer to this question in our GitHub repository. I'll also include this link in the description below. Now here's a recap of what we learned in this video. The range type is used to create a sequence of numbers. Range is commonly used in for loops to iterate the loop a certain number of times. We cannot use floating point numbers inside range.
You've probably heard that Python is an object-oriented programming language. In this video, you will learn what object-oriented programming is and why it is used. After that, we will implement the object-oriented style of programming in our code by creating 2 practical examples. So let's get started. Suppose we need to store the name and marks obtained by university students And based on the marks obtained by the students, we also need to find out if they passed or failed their exam. Then the structure of our code would look something like this. Now imagine that instead of one student, you have to do this for numerous university students. If you were to use the same approach, our code would be less organized and it would look messy. Since these data and functions are related, it would be amazing if we could treat them as a single entity. We can do exactly that by creating objects. This helps us to make programs more organized. Now there are two steps required to create objects. First, we need to define a class. Since we are working with students, we can create a class named student. This student class acts as a blueprint for the objects. All objects created from this class have name and marks data and can use the check pass fail function. Think of a class as a blueprint of a house. It contains all the details about the floors, doors, windows, etc. Based on these descriptions, we build the house. The actual physical house is the object. As many houses can be made from a house's blueprint, we can create many objects from a single class. So from our student class, we can create as many student objects as we want. The concept of object-oriented programming is not native to Python and is available to most of the programming languages. Now that we know what objects are, let's implement them in Python. As mentioned before, we need to define a class before we can create objects. Let's do that first. And here I'll say class student and then I'll just use pass. Here I have defined a class named student. At the moment our class doesn't have any attributes and methods. Since classes cannot be empty, I have added a pass statement so that I can run the code without any errors. By the way, when working with objects, variables are called attributes and functions are called methods. From now on, we will be using these terms when working with objects. Now that we have defined a class, we can create as many objects as we want from it. Let me create two objects of the class. I'll say student1 equals student in parentheses, and then I'll say student2 equals student and again parentheses. Here student1 and student2 are both objects of the student class. Now we can start adding different attributes to these object instances. First, let me remove the student2 and here I'll say student1.name equals Harry. Here we have assigned Harry to the name attribute of the student1 object. Let me add another attribute to our object. So here I'll say student1.marks equals 85 and I'll print these attributes. I'll say print student1.name and print student1.marks. Now when I press run, I get Harry and 85 back. We have successfully added two attributes to our student1 object. However, this is not the proper way to add attributes to objects. Usually, what we want to do is we want to put attributes inside our class so that all the objects created from the class have these attributes by default. Similarly, we also put all methods inside our class so that every object of the class can access them. Let's first see how we can add methods inside a class. Then we will look into the proper way to create attributes. Here I have defined the check pass fail method inside the class. Now any object created from this class will have access to the check pass fail method. If you have noticed, we have used self as an argument here and self.marks inside the method. We will talk about that in a moment. Let's first access this method using the student1 object. So at the end here I'll say did_pass equals student1 dot check underscore pass underscore fail, and then I'll remove these two lines and I'll say print did_pass. Now when I press run, then as expected it prints true because the student1 has enough marks to pass.
Let's see from the very beginning what's going on here. We have created a class and we have defined a check pass fail method inside it. Then we created an object from this class and added two attributes, name and marks, to it. Finally, we called the check pass fail method using the student1 object. We have called this method without passing any arguments. However, the method definition has an argument called self. Now you must be thinking, shouldn't this give us an error? Well, whenever we define methods for a class, we need to use self as the first argument. This self represents the object calling it. In our example, self refers to the student1 object and self.marks refers to the marks attribute of the student1 object. So the object is passed as the first argument automatically. If we create another object, let's say student2, and call this method, then self represents the student2 object and self.marks represents the marks attribute of the student2 object. Let's try it out. Student2 equals student2 dot name equals Janet, student2 dot marks equals 30, did underscore pass equals check pass fail, student2 dot check pass fail, and let me print did underscore pass. Now when I press run, then I get true first and I get false. Here marks of student1 is 85, so in this method self.marks is 85, which is greater than 40, that's why true is returned. Similarly, for student2, student.2.marks is 30, so self.marks greater than equals to 40 is false, that's why we get false. By the way, we can use any name instead of self here. It's just an identifier like variable names. Using self is a convention, and for consistency, we will also keep using self. Adding attributes to the object manually after defining it is not a good practice. Instead, Python offers a much more elegant and compact way of defining attributes right while instantiating the object. For that, we use the init method. The init method is a special method that automatically gets called every time objects are created. If you're coming from other programming languages like C++ or Java, the Python init method closely resembles constructors. So let's see how we can use the init method in our code. And I'll remove the student2 code, and I'll also remove the code that adds the attributes of name and marks to the student1 object. Then I'll say def underscore underscore init underscore underscore self name marks, and I'll say self.name equals name, self.marks equals marks, and here I'll say Harry and 85. Now let me also remove this did pass, and I'll say print student1.name and print student1.marks. Let's see what's happening here. When we create an object, this init method is called automatically with the values Harry and 85 passed to name and marks automatically. Remember, the first parameter self represents the object calling it, while the second and third parameter take the two arguments which we used during object creation. Now for the student1 object, the name attribute will be Harry because of the statement self.name equals name, and marks will be 85 because of the statement self.marks equals marks. When I run this code, then I get Harry and 85. Let's create another object. First, I'll add another student, student2 equals student Janet 30, and let me print those. So I'll say print student2.name and print student2.marks. Now when I press run, then I get Harry, 85, Janet and 30.
Now let me check if student 1 and student 2 passed or failed the exams. We already have the check pass fail method defined for this purpose. We just need to call it. But first I'll remove the code to print the attributes, and then I'll say did underscore pass equals student1 dot check pass fail. Let me print did underscore pass, and again I'll modify did pass so that I know the value or the pass fail status of student 2. So I'll say did underscore pass equals student2 dot check pass fail, print did underscore pass. You must have guessed the output by now, but let me run the code and verify anyways. So I'll press run, and as expected, true and false are returned, because in this line did underscore pass will be true since the first student Harry has enough marks to pass the exam. Similarly, here did pass will be false because student 2 does not have enough marks to pass the exam. Let's see how this program works from the very beginning again. We have created a class with two methods, an init method that initializes the attributes of name and marks, and a check pass fail method that returns true if the marks is greater than 40, greater than equals 40, and false if it's not greater than equals 40. We then created student 1 in this line with the parameters Harry and 85. When this object is created, the init method is called, and name and marks attributes of this student 1 object are now Harry and 85. Then we checked if student 1 passed the exam and printed the result. We had also created another object student 2 by passing Janet and 30, so the name and marks of the student 2 object are Janet and 30. And then we calculated if the student had passed or not using the check pass fail method of the student 2 object, and we printed the result. I hope you have some idea of how classes and objects work by now. Let's try one more example for extra clarity. In this example, we will add two complex numbers manually. Python already handles this by default, but we will create our own complex class to better understand the concepts of object-oriented programming. If you do not know, a complex number has real and imaginary parts. When we add two complex numbers, we need to add the real and imaginary parts separately. Let's first create a class that represents complex numbers. I'll remove this old code and I'll type class complex, and here I'll define an init function. So I'll say def init self real image, and inside this I'll say self.real equals real and self.imaginary equals image. And now let me create two objects, n1 equals complex 5, 6, and n2 equals complex -4 and 2. At this point, we have created two complex numbers n1 and n2 and initialized the real and imaginary parts. Now we'll create a method to add these complex numbers. So inside our class, I'll add the code. I'll say def add self number, and here I'll say real equals self.real plus number.real, and I'll say image equals self.image plus number.image. Then I'll say result equals complex real image, and I'll return this result object. Now let me call the add method. So here I'll say result equals n1 dot add n2. Here we have called the add method on the n1 object and passed the n2 object to it. So inside the add method, self will be n1 and number will be n2. Then the real and imaginary parts of these numbers are added separately. So real equals self.real plus number.real means n1.real plus n2.real. Similarly, image equals self.image plus number.image means n1 because n1 is self, n1.image, and number
is n2, so n2.image. We have then created another object of the complex class using the result values and then returned it in the next line. Now let's print the attributes of the result object. I'll say print real equals result.real and print image equals result.image. Now when I press run, there seems to be a problem, I forgot the colon. Now when I press run, then I get real equals 1, image equals 8. Let's verify. So 5 minus 4 is 1 and 6 plus 2 is 8. So the answer is correct. As you can see, the real and imaginary parts have been added separately as expected. Why object-oriented programming? As we have seen from our examples, creating objects allows us to organize related data and functionalities together. This helps us to write structured and flexible code. Now instead of thinking in terms of individual data and functions, we start thinking in terms of objects and how one object interacts with the other. This helps us to divide a complex problem into smaller subproblems. Also, using an object-oriented style of programming makes our code reusable because we can define multiple objects with similar attributes and functionalities from a single class. Before we end this video, here's a task for you. Create a class named triangle. Create an object from it. The object will have 3 attributes named A, B, and C that represent the sides of the triangle. The triangle class will have 2 methods, the init method to initialize the sides and a method to calculate the perimeter of the triangle from its sides. The perimeter of the triangle should be printed from outside the class. Here's the bare bones code for the program. You'll find the complete answer to this question along with source code of all the programs in this video in our GitHub repository. The link will be in the description below.
If you're enjoying this video, please also check out Programiz PRO, where we provide tutorials along with quizzes and challenges which will help you practice and test your learning in real time. Also, the course includes projects to give you an awesome experience of how programming works in the real world. And for our YouTube subscribers, we are giving 50% off on the yearly plan. Sign up by scanning this QR code or use the link in the video description to claim your discount.
You probably heard Python is an object-oriented programming language numerous times at this point. This means Python supports user-defined classes and objects. One thing that is particularly interesting about Python is that you can not only create custom objects, but every pre-existing thing available in Python is already an object, whether it's strings, numbers, functions, or even classes. In this video, we will learn to check the type of objects, find their attributes and methods, and have a solid understanding of Python objects, which will help you become a better Python programmer. Everything in Python is an object, and we can check this using the type function. Let's try it out. I'll go to my code editor and I'll say numbers equals 1, 4, 9, 16. And let me say print type numbers. Let me run this code. In the output, we see class list. This means the numbers list is an object that is instantiated from the list class. Let's try a few more examples. So let me create a number. I'll say n1 equals 5 and let's print the type. I'll also try a few other data types. So I'll say flag equals true, print type flag. Let me also try a function. So I'll say def my underscore function and I'll create an empty function. Now let me say print type my underscore function. Now when I press run, we can see that all these entities are instantiated from a class, which means they are all objects. We can list out all the attributes and methods of a given object by using the dir function. Let's try it out. Let me remove this code first and I'll say numbers underscore list equals 1, 2. In the next line, I'll say print dir numbers underscore list. Now when I press run,
This means that our list can access all these attributes and methods. Let's use the underscore underscore add underscore underscore method. That's the first element of this list. It is used to append all the items of another list to the end of the current list. So I can say, let me first comment this out, then I'll say result equals numbers underscore list dot underscore underscore add underscore underscore, and then let me add another list 3, 4. Now let me print the result and see what we get. When I press run, then I get a list that has 1 and 2 and the elements of the other list appended at the end. By the way, we can also accomplish this task by using the plus operator like this. I'll first comment out this code and then I'll say result equals numbers underscore list plus 3, 4. When I press run, then I get the same output as before. In fact, the plus operator internally calls this same underscore underscore add underscore underscore method when working with lists. That's why we can use the operator like this. As you can see, even though we are working with operators, we are actually using attributes and methods of the object internally. Let me uncomment this code and run it again. If you look at the attribute of lists, we can see append, clear, copy, count, and many other methods that we have been using from before. So if you're unsure about what attributes and methods an object can use, the dir method can be useful. The id function. In Python, every object has an id for identity. The id of an object is always unique and constant for this object during its lifetime. We can check the id of an object by using the id function. Let's try it out. So in my code editor, I'll remove this old code and I'll say number1 equals 5 print id of number1, and let me create another number. So I'll say number2 equals 10 print id of number2. Now when I press run, then you can see two numbers 978 4992 and 978 5152 are printed. This is the id of the number1 object and this is the id of the number2 object. Let me modify this program and I'll assign number1 to number2. So here I'll say number2 equals number1, and when I press run now, you can see that both of these IDs are the same. This is because we are working with the same object. Python does this for memory optimization. Suppose we have a code like this. In our previous videos, we have been saying that 5 is stored in A, but this is technically wrong. Here, A is more like a name tag and it can refer to any value. Currently, it is referring to object 5. Now, if you create another variable B and assign A to it, then both A and B will refer to the same object. Let me give you another example of this. Suppose we have a list like this. So I'll say A equals 1, 2, 3. Let me assign this variable to another variable. So here I'll say B equals A. Now I'll modify A by adding one more element to it. So I'll say A dot append the element 4. Next, let me print the values of A and B. So here I'll say print A equals A and print B equals B. I'll run this code and you can see A and B both have the same value even though I've made no changes to B. This is because A and B are referring to the same object. As you can see, I've done B equals A. And if we check the ID of the variables A and B, they will be the same. That's why we use the lists copy method to copy one list to another if we do not want this kind of behavior. So here I'll say A dot copy, and now when I press run, then you can see A and B don't have the same value because I have only modified A and B, which was a copy of A, is not modified at all. That's it for this video. You can find the source code of all these programs in our GitHub repository. The link will be in the description below. Before we learn about Python inheritance, let's see an example of why it is used and what problem it solves. Suppose we are creating a racing game that will have cars and motorcycles. To solve this problem, we can create two separate classes to handle each of their functionalities. However, both cars and motorcycles are vehicles and they will share some common attributes and methods. So instead of creating two independent classes, what we can do is create a vehicle class that shares the common features of both cars and motorcycles. We can then derive a car class from the vehicle class. In doing so, the car class will inherit all the attributes and methods of the vehicle class, and we can later add car specific features to the car class. We can also create a motorcycle class that inherits from vehicle in a similar way. This is the basic concept of inheritance. It allows us to inherit attributes and methods from a parent class to a child class. In this example, vehicle is our parent or base class, while car and motorcycle are our child or derived classes. By writing programs in this way, we can reuse code that is common for different classes, and it also makes our code easier to use and maintain. Now that we know about inheritance, let's learn how to implement it in Python with the help of examples. We will derive a dog class from an animal class and get a feel of how inheritance works. Then we will move on to create a more practical example. So I'll say class animal. Let's define a method named eat inside it. So here I'll say def eat self, and inside I'll say print I can eat. This is our base or parent class. Now let's derive the dog class from this class. So here I'll say class dog, and before parenthesis I'll add animal inside braces. Inside this class I will create the bark method, which is specific to the dog class. So here I'll say def bark self, and inside the function definition I'll say print I can bark. This dog class inherits all the attributes and methods of the animal class. This means objects of dog can also access attributes and methods of animal. Let's see how. So here I'll create a new object called dog1, and I'll say dog1 equals dog. Now I can call this bark method on the dog1 object. So I'll say dog1.bark. Now when I run this code, you must have imagined the output already. It says I can bark. Since our dog class is inherited from the animal class, dog1 can also call the eat method defined in animal. So I can say dog1.eat, and now when I press run, then I can eat is also printed because dog1 has access to the eat method of the animal class. Let's see from the very beginning what's happening here. We derived the dog class from the animal class. So the dog class inherits all the features of the animal class. Now this object of the animal class can access attributes and methods of both the dog class and the animal class. Similarly, if we want, we can derive another class called cat from the animal class like this. So here I can say class cat, and inside braces I'll say animal. So inside this class I'll define a method called getGrumpy. So I'll say def get underscore grumpy self, and inside this I'll say print I am getting grumpy. Now let me create an object of the cat class. Cat1 equals cat, and let's call the eat method to see if eat is accessible to cat. So here I'll say cat1.eat, and when I press run, then as you can see, I can eat is printed from the cat1 object as well. As we just saw, cat objects can also use the eat method defined in the parent class. Even from this very simple example, we can see that inheritance makes our code more organized and reusable. Let's now look at a more practical example of inheritance, and we will also cover the concept of method overriding in our example. We are going to implement a program to calculate the perimeter of different polygons like triangles and quadrilaterals using inheritance. Here's what we will do. We will first create a polygon class that has an init method, a method to calculate perimeter, and a method to display the definition of a polygon. We will then derive two classes, triangle and quadrilateral, from it. In these classes, we will add methods specific to them. Let me first create a base class called polygon. So in my code editor, I'll remove the old code and I'll say class polygon, and inside it I'll create an init function def underscore underscore init underscore underscore and pass in self, and I'll pass in the sides as the second argument. So here I'll say self.sides equals sides. To make things easier, we will make the sides attribute a list that will contain all the sides of a polygon. Now let me add a display info method to display information about this polygon. So here I'll say def display underscore info. It will also take the self parameter by default, and inside I'll say print a polygon is a two-dimensional shape with straight lines. Let me also add a perimeter method that will find the perimeter of this polygon. Remember that perimeter is the sum of all sides of a polygon. So in my code editor, I'll define the perimeter method as, I'll say def get underscore perimeter self perimeter equals self sum self dot sides. Sum is a function that can act on a list and provide the sum of the elements of that list. So then I'll say return perimeter. This will be our base class. All polygons like triangles and quadrilaterals will derive these features. Now that we are done creating the base class, let's create a triangle class that will inherit from the polygon class. So I'll go here and I'll say class triangle, and then because we want to inherit from the polygon class, inside parenthesis I will say polygon, and I have my regular colon. Inside the triangle class, I'll define a function called display underscore info. So I'll say def display underscore info self, and the definition of a triangle is print a triangle is a polygon with 3 edges. I'll also define the new quadrilateral class. So I'll say class quadrilateral, and also again derived from polygon, and inside it I'll say def display underscore info self. Now let me define a quadrilateral. I'll say print a quadrilateral is a polygon with 4 edges. Here in each of these cases we have defined a child class from the parent polygon class that will inherit all the attributes and methods of the polygon class. Now let's find the perimeter of a triangle. First I'll create an object of a triangle class. So I'll say t1 equals triangle. Let me pass in the sides of the triangle. When we create the t1 object, the init method of the polygon class is called automatically. Now let's find its perimeter. So here I'll say perimeter equals t1 dot get underscore perimeter. This code calls the get perimeter method that is defined inside the polygon class and returns the perimeter of the t1 triangle. Let's print perimeter and run the code to see if our program is working correctly. So I'll go back down and I'll say print the perimeter is, and I'll say perimeter. Now when I press run, Then there seems to be an error. Okay, triangle object has no attribute get parameter. So I have called get underscore parameter correctly. Oh, I've misspelled parameter here. Now when I press run, then it says the parameter is 18. So 5 plus 6 plus 7 is 18. That means my answer is correct. As we can see, we get the parameter as expected. If you've noticed, we have this display underscore info method in both the polygon class and the two derived classes as well. Let's see what will happen if we call the display info method for the T1 triangle. So here I'll say T1 dot display underscore info, and when I run the code, we can see that the display info method of the triangle class is called instead of the display info method of the parent class. This is called method overriding. If the same method is defined in both the base and the derived class, then the method of the derived class overrides the method of the base class. Let's see from the very beginning what's happening here. We defined a polygon class and created three methods inside it: the init method, the display info method, and the get parameter method. Then we derived two classes, triangle and quadrilateral, where we again define the display underscore info method. Inside the display method of the triangle and the quadrilateral classes, we define specific details of both triangles and quadrilaterals. This is called method overriding. Due to this, when we call display info using triangle objects, it doesn't use display info of polygon, rather its own display method is called. By the way, if we need, we can call the display info method of our parent polygon class from inside its child classes like this. Here, inside the display info method of the triangle class, I can say polygon dot display underscore info and self. When I run the code, then it also prints a polygon is a two-dimensional shape, which means the display underscore info method of the polygon class was called correctly. As we can see, the print function inside the display info of the triangle method was called first, and then only after that the polygon class's display info function or method was called. Here, polygon is the name of the parent class. Since we are calling the method using the class rather than an object, we need to pass self explicitly here. This code is a bit more unorthodox than what we have been using. There is a more elegant way to achieve the same task by using the super function like this. So here, instead of polygon, I'll say super, and when I press run, it says display info takes one positional argument but two were given. This means I don't need to pass self. When I press run, then I get the same output. The super function returns a temporary object of the superclass for a subclass. Simply speaking, super is an object of polygon in this example, and we are using it to call display info of the polygon class. That is why it threw an error when I had self here, because super is an object and not the class name. We can use this to access the method and attributes of a parent class from inside a child class. At this point, we have covered all the fundamentals of Python inheritance. By the way, we haven't used this quadrilateral class in our example yet. If you want, feel free to create objects of the quadrilateral class and try accessing the available methods as you please. It will help you understand these concepts much better and get a feel of how things work in object-oriented programming. By the way, you can find all the source code mentioned in this video in our GitHub repository. The link is in the description below. Let's talk about Python modules. A module is a file that contains Python code that we can use in our program. In this video, we will learn why modules are used and how we can use them in our program. Then we will learn to create custom modules with the help of example. There are several built-in functions like print, input, and sum that are readily available to us. In addition to these functions, Python also has several functions that are defined inside a module which we can use after we import them. Let me give you an example to show you what I mean by this. So I'll go to my code editor. This time I am using the VS Code editor because I need to be working with multiple files, and that feature is not in our online compiler yet. So here in my code editor, I'll create a new file called main.py, and inside this file, I'll say import math. This will import the math module that comes when we install Python. This module contains many mathematical functions and constants. Let's use the square root function from this module. This function is used to calculate the square root of a number. So here I'll say number equals 25, result equals math.sqrt number, and then let me print the result. Now I'll save this file, and to run it I have to say python main.py. When I press enter, then you can see that 5.0, which is the square root of 25, is printed. Now let's access the pi constant defined inside this module. In my code editor, I'll say print math.py. Now let me save this file and run this code again. And you can see that 3.141592, the value of pi is printed. So once we import a module, we can use everything inside it using the dot operator. While importing a module, we can also rename it to a different name as per our needs. Let me demonstrate this with an example. In my code editor, I'll add import math as m. Now we can access the math module and its definitions using m instead of math. So here and here I need to replace math with m, and I'll save this file and run this code again, and as you can see, my code still works because math is now imported as m. When we import a module like in our previous examples, everything in the module is available to us. However, if we only need to import a specific definition like a function or a constant, we can use the from import statement. Let's try it out. In my code editor, I'll remove this old code, and here I'll say from math import sqrt. Now num equals sqrt 64, and now let me print the result num, and I'll save this file, I'll run this code, and as you can see 8.0, which is the square root of 64, is printed. Here only the sqrt function is imported from the math module. When we use this syntax, instead of math.sqrt, we need to directly use the sqrt function. We can also import multiple definitions from the module in a single line using this syntax. Let me import the constant pi and the functions sqrt and sine from the math module. So in my code editor, I'll say from math import pi, sine and sqrt, and let me calculate the value of sine pi by 2. So I'll say value equals sine pi by 2, and let me print this value. I'll save this file and run my main.py file, and as you can see 1.0, which is the value of sine pi by 2, is printed. We can also use this from import statement to import all definitions from a module like this. So here, instead of manually importing pi, sine and sqrt, I can also do from math import asterisk. I'll save this file, I'll clear the screen, and then let me say python main.py. When I press enter, then you can see my code still works, and sine, sqrt and pi are still imported. Here asterisk means import everything. A side tip for you, importing every definition name with the asterisk symbol is a bad programming practice, and you should try to avoid it in your code. The math module comes with many more handy functions and constants. We can list out all the things defined inside a module by using the dir function. Let's list out all the definitions of the math module. So in my code editor, I'll remove this old code, and here I'll say import math, and then I'll say print dir math. I'll save this file and again run main.py. As you can see, there are many other mathematical, trigonometric and logarithmic functions inside the math module. By the way, the math module comes when we install Python, and that's why we can import it directly. There are many popular modules that are not natively available for us to use. For example, NumPy is a popular package that is used for scientific computing. To use NumPy, we must first install it.
Similarly, you might have heard about Django. It's a popular framework used for creating web applications. It's also available only after we install it. To keep this video short and to the point, we will not cover about installing such modules here. If you're interested, you can find plenty of resources about it on the web. Custom modules. Now let's learn about creating custom modules. In Python, we can also create our own custom modules as per our needs. This helps us to keep our code organized. Here, we'll create a module named calculator that will contain functions to perform arithmetic operations. So in my code editor, I'll create a new file named calculator.py. And inside calculator.py, let me create 4 arithmetic functions. So I'll say def add a comma b. This should return the sum of a and b. Similarly, I'll say def subtract a comma b. This should return the difference of a minus b. Def multiply a comma b. This should return a multiplied by b. And lastly, def divide a comma b, and this should return a divided by b. This file is in itself a module. Let's import this file from the main file. So I'll go to the main file, and here I'll say import calculator, and let me use the functions using the dot operator as we previously discussed. So here I'll say result 1 equals calculator dot add 2 comma 3. Now let me print result 1. Similarly, result 2 equals calculator dot subtract 6 comma 3. Here I'll say print result 2. Similarly, result 3 equals calculator dot multiply 10 comma 3. Now let me print result 3. And finally, result 4 equals calculator dot divide 6 comma 3. And let me print result 4. Let me save this file, and here I'll say python main.py. Now when I press enter, then you can see that all these calculations were correctly done. In our example, we have only used functions and constants from a module. However, a module may also contain classes or any other definitions. From this very simple example, we can already see how useful a module is. It helps us in better code management and improves reusability of our code. That's it for this video. If you want to revise these concepts, you can find all these programs in our GitHub repository. The link is in the description below. Let's talk about Python packages. A package is a directory containing multiple modules and other sub-packages. In this video, we will learn about Python packages with the help of examples. Then we will learn about pip, the standard package manager of Python. Suppose we are developing a large program. To simplify this program, we can first divide it into modules. If our program is very large, there might be a lot of these modules. So we further need to group related modules together so that everything is organized. Python packages allow us to do just that. They help us to organize related modules together. Let's look at an example to understand this concept even more clearly. Suppose we are developing a game with multiple objects, so it may have these different modules. Since these modules are in the same location, they look cluttered right now. We can structure them in this way instead. Here, the similar player and boss modules are kept under the characters package. Also, gun and knife modules are kept inside the weapons package. Then, both characters and weapons packages are again kept inside the main game package. As you can see, our project looks much more organized and structured with the use of packages. Now let's try to implement this in our code. To keep this video short and to the point, I will only implement the characters package, but you will soon see that the core concept will be the same for other packages as well. I'll first create a package named game that will contain all our game components. So let me go to my code editor and I'll create a directory named game. Then I'll create a file named init.py inside it. So I'll say __init__.py. This is a special file which will tell Python that this directory is a Python package.
I'll leave this file empty for now. Now let me create a sub-package inside this game package. So here I'll create a new folder called Characters. Since this will also be a package, let's not forget to add the init.py file inside the characters folder as well. This will tell Python that characters is also a package, or it is a sub-package of the game package. Now I'll create two modules inside this package. So let me create the player.py module first. So here I'll say player.py, and inside this file let me add a function. So I'll say def get player info, and inside this function let me just say print I am the main player. So let me save this file, and then I'll create another module called boss.py. So I'll say boss.py, and inside this boss.file let me just add one function. I'll say def get boss info, and inside this function I'll just write print I am the enemy player. I'll save this file. Here I have just used a simple function to illustrate Python packages. However, while actually developing such large programs, these modules might contain classes and multiple functions. Now let's try to import each of these components by using the import statement. I'll create a new file outside the game package and I'll call it main.py. So here I'll say main.py, then I will say import game and use the dot notation to access the player module inside the characters package. So I'll say import.characters.player. Now I can use all definitions inside the player module. Let's use the getPlayerInfo function of the player module. So I'll say game.characters.player.getPlayerInfo. Let me wrap this up so that you can see it. Okay, I said info. So I'll save this file, and here on the terminal I'll say Python main.py, and as you can see the function was correctly called and I am the main player is printed. We can also use the from import statement to import only certain modules from the package. Let me show you how to do this. I'll first remove this old code, and here I'll say from game.characters import player. Here we have only imported the player module of the characters sub package, so we can access the getPlayerInfo function without using the game package. So I'll only type player.getPlayerInfo. I'll save this file, run main.py again, and you can see that I got the same result as before while writing lesser code. We can also import only certain definitions from inside these modules as well. I will now import only the getBossInfo of the boss module. So here I'll say from game.characters.boss import getBossInfo. Now I can call the getBossInfo directly. And if I save this file and run the code, then you can see I am the enemy player was also printed. Both functions work as expected. A tip for you, when you use packages, always try to give descriptive names to functions and classes so that you don't get confused. Now we have created this init files without doing anything inside them. The code inside this file runs automatically when we import the package. Let me add a line here inside the init file of the game package. Here I'll say print initializing the game. Now let me go back to my main.py file, and if I run the code again, so here I'll say Python main.py, and when I press enter, you can see that initializing the game was also printed to the screen. That means the code within the init file was executed when the package was imported, and that is why initializing the game was printed here.
In our previous example, we looked at how to create a Python package. There are thousands of such useful packages tailored for specific tasks that are developed and maintained by the active Python community. When you start working on more advanced projects, you will have to use these packages at some point rather than building everything from scratch. For example, if you're working with web development, you will probably use packages like Django or Flask. To use these packages, we first need to install them. This is where pip comes in. Pip is the standard package manager for Python that helps to install and manage additional packages that are not available in the Python standard library. Let's use pip to install a package called pandas. It is a popular package for data analysis in Python. To install this package, I'll say pip install pandas. And when I press enter, as you can see, it's downloading the pandas package. Depending upon the size of the package, it may take a while. One cool thing about pip is that it also automatically installs all required dependencies to run pandas like NumPy, which is another popular package for scientific computing. Now that the process is complete, I will open a new file, and inside it I'll write from import pandas as pd. Now I just want to check if the pandas module is working, so here I'll just say print pd and save this file. Now here I'll say python main.py. As you can see, pandas is correctly installed and we can start using it in our code. Sometimes you may have to install a specific version of a certain package. In that case, you can specify the package version using the double equal syntax. Let me show you. I'll go to my terminal and I'll type pip install requests equals 2.21.0, and as you can see, it is collecting and installing the specific version of request that I requested for. If you want to list all the installed packages, you can use the pip list command. So in my terminal, I'll clear this out and I'll say pip list. As you can see, it printed out all the packages that I have installed on my computer. As you can see, pip is a very useful tool that makes managing external packages a whole lot easier. If you want to learn more about pip, you can check out our article on it. The link will be in the description below. I'm sure you have run into errors numerous times while programming. Basically, these errors are of two types. One is syntax errors like missing parentheses, wrong indentation, etc. You can easily fix these errors by fixing the syntax. And the other type of error is exception. Even if your code is syntactically correct, it may sometimes result in an error. For example, if you divide a number by 0, you will get an error. These types of errors that we encounter during the runtime of the program are called exceptions. In this video, we will learn about exceptions in detail, and then we will see how we can handle them in Python. Let's understand about exceptions first. For this, I will write a program that will give us an error. So in my code editor, I'll say numerator equals 10, denominator equals 0. Now I'll say print numerator divided by denominator, and I'll save this file. Let me run it. I'll say python main.py, and you can see that when I run the code, we can see the 0 division error has been raised. Even though our code was correct syntax wise, it's not allowed to divide a number by 0 in Python. This is an exception. In this case, we are getting the 0 division error exception. Depending upon the error, these exceptions can be of different types. For example, if we try to access a file that doesn't exist, we will get the file not found error exception. Similarly, if we try to access the item of a list out of range, we will get the index error exception. As we know, when our program encounters an exception, our code ends abruptly with an error message. And most of the time, rather than showing the default message, we may want to show a custom message that's more helpful or run a different set of code. This is known as exception handling. It's the process of responding to exceptions in a custom way during the execution of a program. In Python, we use the try except block to handle exceptions, and its syntax goes like this. Inside the try block, we write the code that might throw an exception. Now if an exception occurs, the control of the program jumps immediately to the except blocks and the program continues. And if exceptions don't occur, the except block is completely skipped. Pretty simple, right? Now let's see a working example of it. So inside the try block, I will write some code that might raise an exception. Let me remove this, and here I'll say numerator
equals integer input, enter numerator, then I'll say denominator equals integer input, enter denominator. Next I'll say result equals numerator divided by denominator, and let me print the result. Here we are taking numerator and denominator from the user, dividing the numerator and by the denominator, and then printing the result. This code may raise an exception if the user enters 0 as a denominator. Let's print a simple message inside the except block if an exception occurs. So I'll remove this code, and here I'll say print denominator cannot be 0, please try again. Let me also put another print statement outside the try except blocks. Here I'll say print program ends. Let me save this, and when I run this, so I'll go to my terminal and say python main.py. In the numerator I'll enter 10, in the denominator I'll enter 0, and as you can see, denominator cannot be 0, please try again is printed. This is because this line result equals numerator divided by denominator raises an exception when denominator is 0. In this case, the control of the program jumps to the except block and the code inside it is executed. Let me run this program again. So here I'll say python main.py, and this time let me enter the numerator as 4 and denominator as 2. When I press enter, as you can see, the correct answer, which is 4 divided by 2, is printed, and the except block is not executed this time. I have this code from our earlier example on my screen. Here it doesn't matter what type of exception it is, this except block is executed whenever an exception is thrown. It's also possible to handle different types of exceptions in different ways. For example, we may want to print different error messages for zero division error and index error exceptions. We can do that by specifying the type of exception after the except keyword. So here after except, I will add zero division error. Now this except block is only handling the zero division error. Let me run this code. So here I'll clear this and let's say python main.py, enter numerator 10 and enter denominator. Again I'll enter 0 because I want to throw the exception, and as you can see, the code inside the except block was executed. Handling specific exceptions in this way is particularly useful if our try block may raise more than one type of exception. Suppose our try block can raise the zero division error and the index error as well. We want to handle these two exceptions separately. We can do that by adding another except block to handle the index error exception separately. Let me show you what I mean by this. I will add code inside the try block that may raise the index error exception. So in my code, after the print result, here I'll say my underscore list equals 1, 2, 3, and I'll accept input or the index from the user. So here I'll say I equals integer input, enter index, and then I'll print my underscore list I. This code will raise the index exception if the user enters an index greater than 2 because our list only has 3 items. Now to handle the exception, I will type another except block. So here I'll say except index error, and inside this I'll say print index cannot be greater than size of list. Let me add the full stop. Now when I run this code, I'll say python main.py. Oops, there's an error. So the error seems to be print result. No, print. Oh, I forgot a bracket here. Okay, I'll save this and let me say python main.py. It says enter numerator. So let me enter something like 10. In the denominator, I'll enter 5. Now when it says enter index, let me enter something like 5. When I press enter, then you can see that index cannot be greater than size of list, which is the custom message I had put in for the index error is printed. A try statement can also have an optional finally block which is executed regardless of whether an exception occurs or not, and its syntax goes like this. Let me run this code first. So here I'll say python main.py. Now let's understand what's going on in this program. This block of code gives us the zero division error, so the except block wrong denominator is printed to the screen. Finally, the code inside the finally block is also executed. However, if an exception doesn't occur in the try block, this except block is not executed, but this finally block is still executed. The finally block is usually used to perform cleanup actions that need to be executed under all circumstances. Suppose we are working with an external file in our program, we need to close this file at the end even if there was an error while writing to it. In this case, we put the close file function inside the finally block. At this point, we have covered pretty much everything we need to know about exception handling. By the way, we can also create custom exceptions in Python. If you're interested, you can check that article on our website programiz.com. The link will be in the video description.
If you're enjoying this video, please also check out Programiz PRO, where we provide tutorials along with quizzes and challenges which will help you practice and test your learning in real time. Also, the course includes projects to give you an awesome experience of how programming works in the real world. And for our YouTube subscribers, we are giving 50% off on the yearly plan. Sign up by scanning this QR code or use the link in the video description to claim your discount.
We all know about files. They are named locations on our storage device for recording data. Python provides numerous built-in functions to work with these files. In this video, we will see how we can perform various file operations such as reading and writing into files with the help of examples. There are 3 steps we need to follow to work with files. First, open a file. Second, perform the operations such as read content from the file or write data to the file. Third, close the file. Now, let's cover each of these topics in detail. In Python, we use the built-in open function to open files. Here, I have a file named message.txt, and inside it, I have 2 lines of text, I love programming and I love Programiz. To open this file, I will create a new Python file in the same directory and call it main.py. So here I'll type f equals open message.txt. Here message.txt is the location of the file. If this file was in another directory, we would also need to specify the path to this file. And this open function is opening the file which returns a file object which is stored in the variable f. This file object will be used to perform file operations. By default, the file will be opened in the read mode, meaning we can read contents from the file, but we can't modify it. Instead of this, we could also have explicitly specified the file to be opened in the read mode by passing a second argument like this. So here I'll add a second argument and say r. Here r means open the file in read mode. Similarly, if you want to write contents to a file, we should open the file in write mode by using w like this. So I'll remove this r and I'll write w, and this means that I'm opening the file in write mode. These are called file modes, the mode in which the file is opened, and there are 3 commonly used modes in which we can open a file. R for reading contents of the file, W for writing contents to the file, and A for appending more content to the end of the file. Now we know how to open a file. Next we will see how we can read the contents of the file. After we open a file like this, we can read its contents using the built-in read method. So in my code editor, I'll say content equals f.read, and then I'll print the content. First, I have opened the file in read mode. This statement returns a file object. Then using the object, we read the entire content of the file and print it. Before we see the output of this code, I will add a line to close the file. So here I'll say f.close. We should always close the file after working with them. It's a good programming practice. Now let me run this code. So let me hide the Explorer, open the terminal, and here I'll say python main.py, and you can see that the contents of the file message.txt were printed. It's also possible to read only a certain number of characters from a file using the same read method. For this, we pass an optional size argument. Let me read only the first characters from the file. So here I'll say f.read 6. Let me save this file, and when I run it, you can see that only the first 6 characters of the file were printed. Now if we read the same file again, it starts reading from the 7th character because we have already read up to the 6th character. Let me show you how that works. Let me modify this program to read the next characters. So here I'll say more underscore content equals f.read 12, and I'll print more content. Let me save this, and when I run python main.py again, you can see that programming was also printed. So let's try to see what happened here. The first read statement, or the f.read 6, is giving us the first 6 characters I love. And the second read, which is more content equals f.read 12, is giving us the next 12 characters, and which is programming. We might encounter unexpected errors while working with external files. So it's a good practice to open the files using try finally statement. Let me show you how. So in my code editor, I'll make a few changes. Here I'll put this inside a try block. All of this will go inside the try block, and I will put the f.close inside a finally block. Here we are adding try and finally blocks because now even if our program encounters an error, our file will be closed. This is because the finally block always gets executed. There's even a better way to write this same code in Python using the with open syntax. Let me show you how. So here I'll remove the try block and I'll say with open as f. I'll remove this finally code. Now when I run this code, I'll say python main.py, which should have been with. I'll save this and I'll run python main.py. This again seems to be an error. I forgot the colon at the end. Again, let me try this once. So python main.py, and as you can see, I got the same output, but using the with syntax automatically closes the file without us having to write the finally ourselves. To write content to a file, we must first open it in write mode. Then we can start writing content to it using the write method. There are two things you need to remember while writing to a file. If you try to open a file that doesn't exist, a new file is automatically created. If a file already exists, its contents are removed and our new content is added to it. First, let me write to a file that doesn't exist. So here in my code editor, I'll say with open python.txt, and in write mode as f, I'll say f.write python is awesome, and in the next line I'll write f.write I love Python. I'll save this and let me run it. When I run the code, a python.txt file is created with the content Python is awesome, I love Python. Here both the strings are in the same line. We can change that by adding /n to specify a new line character. So here I'll go back to my main.py and I'll say Python is awesome /n. Now let me open up my terminal and run the code again. So I'll say Python main.py, and if I open the python.txt file, you can see that Python is awesome and I love Python are on separate lines. Notice that while running the program for the second time, the python.txt file was already there. Since opening an existing file in write mode will overwrite the file, all the previous data was erased and new content was written to it. So you have to be very careful while using the write mode because you may accidentally erase the old data without realizing it. The final file mode that we will discuss in this video is append. As suggested by the name, we use this only if we want to add additional data to the end of the file without erasing our previous data. At the moment, our python.txt file looks like this. Let me add an additional line to this file, and in main.file, I'll open this in append mode, and here I'll write f.write. I'll write Python is my favorite programming language. Here I have used A to specify that I want to append to the python.txt file. Then I have used the same write method to write new lines to the existing file. Let me run this code. So let me hide this here, open up my terminal, and here I'll say python main.py, and after running it, if I open my python.txt, then you can see that Python is my favorite programming language has been appended to the end of the file. The readLines method returns a list containing each line of the file. Let's open the same python.txt file we have been working with on read mode. But this time I will use the readLines method. I'll remove this old code. First let me change the mode to read, and then I'll remove this old code. I'll say lines equals f.readLines, and let me print lines to see what I get. Now I'll save this. Let me run the code. So I'll say python main.py, and you can see that I get a list of the lines that are inside the python.txt file. Now if I want, I can use a for loop to iterate through the list to get each line one by one. Similarly, there is also a writeLines method to write multiple items into a file. It writes the items of a list to the file. So I'll go to my code editor, I'll remove this old code, and instead of python.txt, I'll say javascript.txt. Let me open this in write mode. So inside this block, I'll say lines equals JS is also awesome, and in the second item, I'll say /n JS is my second favorite programming language. Now I'll say f.writeLines lines. I hope you must have guessed the output by now, but let me show you anyways. So I'll do python main.py, and when I press enter, then let me close my terminal, I'll go back to my explorer, and you can see that a file called javascript.txt with the two lines JS is also awesome and JS is my second favorite programming language has been created. At this point, we have covered pretty much everything we need to know about file handling in Python. By the way, there are many other built-in methods and file modes available to file objects. If you're interested, you can find more information about it on our website programiz.com. The link will be in the video description. A folder or directory is a location on a computer to store and organize multiple files and subdirectories. Python has a module named OS that makes it really easy to work with directories and file management tasks. In this video, we will learn to use the OS module to perform various directory operations like creating, renaming, and removing directories with the help of examples. Let's see how we can get the path to the current directory first. For that, we use the getCwd function of the OS module. It returns the current working directory as a string. I'll go to my text editor. First, I need to import the OS module. So I'll say import OS. Then I can say current_dir or current directory equals os.getCwd, and now let me print this variable, print current_dir. I'll save this file, run the code, say python main.py, and when I press enter, then you can see that it printed the location of the main.py file or the current directory. In Python, we can change the current working directory by using the chdir method of the OS module. As we saw in our previous section, the present working directory is the directory containing our Python file by default. Let's change the current working directory. I'll start with the old code and I'll say os.chdr, and inside these quotation marks, let me put this location, and then instead of OS, I'll say exceptions, which is the location of the file from the previous video. So here I'm trying to change the default location, and then let me print os.getCwd again to confirm that the current working directory has been changed. So let me run python main.py. As you can see, os.getCwd first gave me the OS folder where main.py was located. When I change the default directory by using os.chdr, then when I call os.getCwd again, this time I get the new directory which I had set as the default directory here. Now if I create a file inside the current directory, our file will be created inside this exceptions folder and not this OS folder. Let me show this in action. So here I'll write to a new file. I'll say with open test.txt. I'll do that in write mode and I'll call the file pointer f. Then I'll say f.write. This is a test file. Now when I press run, python main.py, a new file has been created, and this file, if I check here, then you can't see that file in the OS directory. Instead, if I go to the exceptions directory, you can see that test.txt file has been created, and inside it you can see that this is a test file is there. That means Python is considering the exceptions directory to be the current directory for opening file test.txt in write mode. In Python, all files and subdirectories inside a directory can be retrieved using the listdir function of the OS module. And I'll say print os.listdir, and let me run this. So I say python main.py, and you can see a list of all the files and folders inside this Python videos directory can be seen here. I can also pass an optional path argument to listdir to return files and subdirectories from a specific path. So here I can say exceptions, and if I run this program again, then you can see the files that are inside the exceptions directory. We can create a new directory using the mkdir function of the OS module. In my code editor, I'll say os.mkdir test, and I can run this code. So I'll say python main.py, and if I go into the folder, I can see that there's a new folder called test. If I wanted this text directory to be created in a specific path, I can use the full path location like this. So here I'll say mkdir exceptions/test, and now let me run this. So python main.py, and if I go inside the exceptions folder, then you can see that there's a test folder inside the exceptions folder. We can rename any directory or file using the rename function of the OS module. Let me show you how. os.rename, and inside this let me pick any file or folder. I'll rename test. So here I'll say test, and I can say test new. And now if I run this code, so I'll say python main.py. Then if I go back to my folder structure, you can see that test has been renamed to test new. As you just saw, the rename method takes two arguments: the current name of the folder or file and the new name of the folder or file. The rename function can also be used to rename a file with the same exact syntax. I encourage you to change the name of a file on your own, and let me know if it worked in the comment section. We can remove a file using the remove function of the OS module. So I'll go to my folder list, and I can see that there's an exceptions4k.mov file here. I'll remove it using Python. So on my code editor, I'll say print. First, let me start by listing all the files and directories in this folder, and here I'll say python main.py. As you can see, there is a file called python module. Let's remove this one. So I want to remove python modules.mov. Next, I'll say os.remove python modules.mov, and then let me again print os.listdir just to make sure that python modules has indeed been removed. So now I'll say python main.py, and as you can see, python modules is not here. Python modules.mov is not here anymore. To remove a directory, we use the rmdir function. One thing we need to remember when removing a directory is that the directory must be empty, otherwise an exception will be raised. Now, we currently already have an empty directory called test new in our current directory, which we had created before. To remove this directory, I will change my previous code, and here I'll say os.rmdir, and here I'll say test new. Now let me run this. First let me clear the screen. Here I'll say python main.py, And now you can see that test new is here before, but it's not in the new list, or I can also verify this visually. So you can see that test new folder is no longer there. That means it has been removed. That's it for this video. If you want to revise these concepts, you can find all these programs in our GitHub repository. I'll also put this link in the video description. Iterators are everywhere in Python. They are elegantly implemented within for loops, list and dictionary comprehensions, but they are hidden in plain sight. In this video, we will learn about iterables and iterators in Python with the help of examples. We will also create our own custom iterator and see how the for loop actually works. Let's first understand what an iterable is. Basically, anything that you can loop over in Python is called an iterable. For example, a list is an iterable. For an object to be considered an iterable, it must have the iter or iter method. Let's check if lists have this special method. To check this, I will use the dir function which returns all the methods of an object. So here on my code editor, I'll say print dir numbers. Now let me run this code. And here among all these methods, you can see the dunder itr method. Let's call this method on this numbers list to see what it does. So here I'll say value equals numbers dot dunder or double underscore iter double underscore, and let me print the value. When I press run, then you can see that we got a list iterator object, and this is the memory location of that object. Next, we will see what iterator objects are. Iterator in Python is simply an object that can return data one at a time while iterating over it. For an object to be an iterator, it must implement two methods, iter or iter and next. These are collectively called the iterator protocol. Now we'll look into the next method in detail. Suppose we have a list like this, so I'll say numbers equals 1, 4, 9. Now I'll get an iterator from this list using the iter method. So here I'll say value equals numbers dot dunder or double underscore under iter and next. Here this variable value is an iterator, and we can get each element of this iterator by using the next method. The next method returns the next value in the iteration. So here I can say item1 equals value dot double underscore or dunder next, and then I can print item1. When I run this code, then 1, which is the first element of this list, is printed. Now if I run the next method again, it should return the next item, which is 4. It's because the next method also updates the state of the iterator. And here I'll say item2 equals value dot dunder next, print item2, and then item3 equals value dot dunder next, and then I'll say print item3. Now let me run this code. As you can see, first 1 was printed, then 4, then 9. By the way, instead of calling these special methods with an underscore, Python has an elegant way to call underscore underscore iter simply with the iter function and underscore underscore next underscore underscore with the next function. I'll make these changes to my previous code. So here, instead of calling numbers dot underscore underscore iter, I can say iter numbers, and instead of calling value dot underscore underscore next underscore underscore, I can say next value. Here too, I can say next value, and here as well next value. When I run this code, I get the same output as before, but my code looks a lot cleaner than before. By the time I get to the third element, we have already reached the end of our list. Now let's see what happens if we further try to get the next value. So here I'll say item4 equals next value, and let me try to print item4. Now when I run the code, then you can see that the stop iteration exception has been raised. Since our list had only 3 elements, the call to the 4th next method raised the stop iteration exception. Did you know that for loops internally use the while loop to iterate through sequences? To demonstrate this, let me first loop through a list using the while loop. So I'll go to my code editor and create a new list. I'll say num underscore list equals 1, 4, 9. And now let me create an iterator object. So here I'll say iter underscore obj or iterator object equals iter num underscore list. Here the iter object is an iterator. We can now use an infinite while loop to get the next element using the next method, and in case a stop iteration exception occurs, we'll break out of this loop. So here I'll say while true, and then I can say try to get the next element. So next iter underscore obj, and then if I get the element, print that element. Now if there's an exception, then I can say, or if there's more specifically, I'll say if there's an stop iteration exception, then break the code. Here's how this code works. First, we have created an iterator object from a list using the iter function. Then we have created an infinite while loop. Inside the loop, we have used the next method to get the next element in the sequence. In the next line, we have printed that element. We have put all this code inside a try block, and when all the items of the iterator are iterated, the try block raises the stop iteration exception and we break out of the loop. Let me run this code, and you can see that 1, 4 and 9 have been printed. In fact, this is exactly how for loops work behind the scenes. A for loop internally creates an iterator object and iterates over it, calling the next method until a stop iteration exception is encountered. As we have already seen, iterators are simply objects that implement the iter method and the next method. Let's try to make our own iterator object. Here we'll create a program that will generate a sequence of even numbers such as 2, 4, 6, 8 and so on. For this, I'll create a class with the init method. So let me remove this old code, and here I'll say class even, and inside this let me start by creating the init method. So I'll say def underscore underscore init underscore underscore self and max, and then let me initialize self.n equals 2, so that's the first value which is always 2, and self.max is the value that we provide. By now we already know that iterators must implement an iter method which returns an iterator. So I'll simply create an iter method that returns the object itself. So here I'll say def underscore underscore iter underscore underscore self, and here I'll say return self. Now let's implement the next method. This method should give the next element in the stream if it exists. If the next element is not available, it should raise the stop iteration exception. So here I'll say def underscore underscore next underscore underscore, oops, I forgot a bracket here, self, and here inside this method we want to generate a sequence up to the max number, and if the next element exceeds max, we will raise an exception. So let me first start with the framework of the code. Here, if self.n, as long as it is less than self.max, then we need to do one thing, and else we need to raise the stop iteration exception. Now inside this if, I need to generate the next number in the sequence. So here I'll say result equals self.n. I am temporarily saving the current value of n in the result variable. Now I want to increase the value of n by 2. So here I'll say self.n plus equals 2 and then return result, because I want to return the old value of n, not the new one. Now our class is finally complete. Let's create an object from this class which is an iterator, because it implements both the iter and the next methods. So here outside the class I'll say numbers equals even 10. Now when I call the next method, I should get even numbers one after another. Let me print 3 even numbers. I'll say print next numbers, print next numbers, and print next numbers again. Now when I press run, then you can see that 2, 4 and 6 are printed. If we use the next method 3 more times, the stop iteration exception is raised as our sequence can only have numbers up to 10 because of this limit here. At this point, we have covered all the basics of iterators in Python, but you might be wondering why it is used. Iterators are powerful tools when dealing with a large stream of data. If we use regular lists to store these values, our computer would run out of memory quickly. With iterators, however, we can save resources as they return only one element at a time. So in theory, we can deal with infinite data in finite memory. Generally, iterators are implemented in Python using something called generators that make it much easier to use them. We will cover Python generators in detail in our next video. That's it for this video. If you want to revise these concepts, you can find all these programs in our GitHub repository. I'll also put this link in the video description. A generator is an elegant way to create custom iterators in Python that make it really easy to work with iterators. If you haven't watched our video about iterators yet, I suggest you watch that video first before you proceed. Before we learn about generators, let's see an example of an iterator implemented in Python. Let me run this code. And you can see that a sequence of numbers 2, 4 and 6 is generated. To generate this, we have created a custom iterator inside the even class. For an object to be an iterator, it should implement the iter method, which will return the iterator object, the next method, which will return the next value in the stream, and possibly raise the stop iteration exception when there are no values to be returned. As you can see, the process of creating iterators is both lengthy and counterintuitive. Generators come to the rescue in such situations. Python generators are a simple way of implementing iterators. All the work we mentioned above are automatically handled by generators. Now let's see how we can use generators to create iterators. I have this code from the last section that creates a sequence of even numbers. Let me first remove this even class. Now let's implement this same iterator using a generator. A generator is simply a function but with slight modifications. In a generator function, we use the yield keyword to get the next item of the iterator. Let's see how. First, I'll create a generator function named even_generator and also change this to even_generator. So let me remove this and I'll call it even_generator. Now let me define the even_generator function. I'll say def even_generator. Inside this, for now, I'll just say pass. Now inside of this function, I will use the yield keyword instead of the return keyword to yield the next value without terminating the function. So here, I'll start with n equals 0 and then I'll increase the value of n by 2 and yield n, and then I'll again increase the value of n by 2 and yield n, and again let me increase the value of n by 2 and yield n, and let me remove this pass. Let's see from the very beginning what this code is doing. First, I've created a generator function that has 3 yield statements. There should be an n here. When we call this function, it returns a generator which is an iterator object. Then we have called the next method to retrieve elements from this object. This code gives us the value of the first yield, which is 2 in this case. This code will give us the value of the next yield, which is n equals 0 plus 2 plus 2, which is 4, and this code gives me the value of the third yield, which is 6. The difference between return and yield is that the return statement terminates the function completely while the yield statement pauses the function, saving all its states for next successive calls. So when we call the next function for the second and third time, it gave us the values of 4, which is the second yield, and 6, which is the third yield. Let me run this code so that you can see it for yourself. So when I run this code, you can see that the same old numbers of 2, 4 and 6 were generated. That means our generator is working correctly. However, as of yet, it only returns the first 3 even numbers. I will now implement a loop to make this generator return even numbers till a certain max number, and here I'll pass in a parameter called max. Now let me remove this old code. Now I'll say n equals 2 And then I'll start a while loop. So I'll say while n less than equals max, yield n, and then increase the value of n by 2. Now I'll say numbers equals e1 underscore generator 4. When I press run, then you can see that 2 and 4 are generated, and after that a stop iteration exception is raised. Let's compare this generator code with our custom iterator code. Notice how we have never explicitly defined the item method, next method, or raised a stop iteration exception. They are handled implicitly by generators, making our program and our life much simpler and easier to understand. Iterators and generators are generally used to handle a large stream of data, theoretically even an infinite stream of data. These large streams of data cannot be stored in memory at once. To handle this, we can use generators to handle only one item at a time. Now let's build a generator to produce an infinite stream of Fibonacci numbers. For those of you who don't know, the Fibonacci series is a series where the next element is the sum of the last two elements. So I'll go to my text editor. First, I'll create a generator function named generate underscore Fibonacci and call it. Here I'll say def generate underscore Fibonacci, and then inside this I'll just write pass and let me call the generate underscore Fibonacci function. It should be Fibonacci. Okay. Now inside this function, I will create the first two elements of the Fibonacci series. So here I'll say n1 equals 0 and n2 equals 1. Let me remove this pass. Then I'll use an infinite while loop, and inside it I will yield the value of n1. So here I'll say while true, and inside it I will yield n1. And then I'll update the values so that the next term will be the sum of the last two terms. So I'll say n1, n2 equals n2, n1 plus n2. If you're confused about what's happening here, what's happening is the sum of n1 and n2 is being assigned to n2, and n2 is being assigned to n1, all in a single line. Isn't Python sweet? Now let me print the first few elements in this series. Here I'll say let me assign this iterator, so seq equals this. Now let me say print next seq, and I'll copy this and paste it a few times. Oops. Alright. When I run this code, you can see that the Fibonacci numbers has been generated. If we had used a for loop and a list to store this infinite series, we would have run out of memory. However, with generators, we can keep accessing these terms for as long as we want. It is because we are just dealing with one item at a time. At this point, we have covered the basics of Python generators. By the way, we can also create generators on the fly using generator expressions. If you want to learn more about it, you can check our article on our website programiz.com. The link will be in the video description below. Now I have a little assignment for you. Why don't you try and modify the generate Fibonacci function to instead generate an infinite stream of odd numbers, so you can call it generate underscore odd, and then use the next method 10 times to print the first 10 odd numbers. That's it for this video. If you want to revise these concepts, you can find all these programs in our GitHub repository. I'll also put this link in the video description. As simple as date and time may seem in real life, they can be challenging to implement in our code because we have to keep record of things such as different date and time formats, different time zones, and so on. Fortunately, Python provides a built-in datetime module to simplify this task. In this video, we will use the datetime module to manipulate date and time in Python with the help of examples. Let's first find the current local date. So in my code editor, I'll say import datetime as dt, and I can say current underscore date equals dt.date.today, and let me print it. So I'll say print current underscore date. Here I have used the today method of the date class of the datetime module, which I have imported as dt,
to get the current local date. Let me open up my terminal, and here I'll say Python main.py, and as you can see, I get 27th January 2021, which is today's date in Nepal. Similar to the date class, the datetime module has many other useful classes to work with date and time. Some of the popular classes defined inside the datetime module are the date class to work with date, the time class to work with time, and the datetime class that is a combination of date and time classes. Now let's cover each of these classes in detail. The date class of the datetime module is used to create date objects that can store year, month, and day. Let me create a date object, so I'll go to my code editor, and here I'll say import datetime as dt, and in the next line I can say date1 equals dt.date. Now the first parameter is the year, so I'll say 2021, and the second parameter is the month between 1 and 12, so let me say January. Similarly, the third parameter is the day of the month, so let me give an arbitrary number like 5, because this needs to be between 1 and 31. So let me close this and let me print what I get. So print date1. So I'll save this code, open up my terminal, and say Python main.py. As you can see, I got the date back as expected. Instead of creating date like this, we can also get today's date as we have previously discussed. Let me get the current date again. I'll remove this old code and I'll say dt.date.today, and let me print the date1 again. And when I run this code, you can see that I get 27 January 2021, which is today's date or the date of this video recording. We can also access the year, month, and day attributes separately. Let me show you how. I'll remove this old code that prints the date, and instead I'll say print year, and let me print date1.year. Similarly, to print the month, I'll say print month, and here I'll say date1.month, and similarly to print the day, I'll say print day date1.day. Now let me save this file, run the code, and you can see that the year, month, and day have been printed separately. The time class of the datetime module is used to create time objects that can store time of day like hours, minutes, seconds, and microseconds. Let me create a time object, so I'll go to my code editor and I'll remove this old code. I can say time1 equals dt.time. Now the time class takes integer arguments which are 0 by default. The first argument is the number of hours between 0 and 24, so here I'll say 10. The second argument is minutes from 0 to 60, so here I'll say 45. The third argument is seconds from 0 to 60, so let me say something arbitrary like 30. And the fourth argument is microseconds from 0 to 1 million. So let me add in a number like 45667. I'll close this bracket. Let me print the time1 to see what I get. I'll save this file. Let me go to my terminal. I'll say Python main.py, and as you can see, I got a time object that stored the same time that I had sent in as arguments to the time class. And if we need, we can also access each individual attribute like the hour and minute separately. Let me show you how. So here I'll say print hour is time1.hour. Similarly, minute is time1.minute, and second is time1.second. Let me save this. I'll go to my terminal, Python main.py, and as you can see, I got the hour, minute, and second separately. Let's also do microseconds. So I'll say print microseconds, and then I can say time1.microseconds. If I save this file, run this code, it says time1.oh, it's microsecond. I'll run this file, and as you can see, I can also get the microseconds. The datetime's time class provides us some of the basic time functionalities. However, if you want more control and functionalities related to time, we suggest you to use the time module.
We already have an article on it on our Programiz website. In case you want to check it out, the link will be in the video description. The datetime module has the date class to work with dates and the time class to work with time. And if you need to work with both date and time at once, the datetime module has also a datetime class. The datetime class of the datetime module is used to create objects that contain all the information from a date object as well as a time object. Let me create a datetime object. So I'll say import datetime as dt. Now let me create a datetime object. So I'll say datetime underscore obj equals dt.datetime. The datetime class takes in all the integer arguments that are used by the date and the time class one after the other. So here I can say 2021, which is the year, 11, the month November, 28, so 28th of November. Then I can say the time is 23 or 11 p.m. 55, so 11:55 p.m. and then 59 seconds, so almost midnight. Let me close the bracket and I can say print datetime underscore obj and let me see what I get. So let me go to the terminal and say python main.py, and as you can see, I get a datetime object that represents the time based on the arguments that I passed here. Now if I only need to get the date from this datetime object, I can always use the date method. So let me hide the terminal and here I'll say print datetime underscore obj and I want to call the date method of this object. So here let me save this file and I'll run python main.py, and as you can see, I got the date object separately. Similarly, to get the time, I can use the time method. So here I'll say print datetime underscore obj dot time. Let me save and run this code, and as you can see, I get the datetime object. Then by using the date method, I separate the date object, and similarly by using the time method, I separate the time object. Like with date and time objects, we can also access individual attributes like year, month and hour as we have previously discussed. To get the current local date and time at once, we can use the now method of the datetime object. So I'll go to my code editor and I'll say import datetime as dt. Now to get the current datetime, I can just say current underscore datetime equals dt dot datetime dot now. Now let me print this. So I'll say print current underscore datetime. I'll save this file, go to my terminal, say main.py, and as you can see, I got the current date and time. So it is 5:48 p.m. on 27th January 2021 right now during the time of this recording. A time delta object represents the difference between two dates or times. Let me show you what I mean. To demonstrate this, I will find out the time difference between now and the next new year. Let me go back to my code editor and say import datetime as dt. Now let me get the current time. So I'll say current underscore time equals dt dot datetime dot now. We already know this. Now the next new year is next underscore new underscore year equals dt dot datetime, and the integers arguments are 2022 and January is 1, and again 1st January is 1. Now to calculate the time remaining, I can say time underscore remaining equals next new year minus current underscore time. Now let me print this and see what we get. So I'll say print time remaining, save this file, go to my terminal, run python main.py, and as you can see, it tells me that there are 330 days, 6 hours, 9 minutes, 0 seconds and 335576 microseconds from now to the next new year. Now let me see what the type of the time remaining variable is. So here I'll say print type time remaining, and when I run this code, you can see that it gives me class datetime.time delta. That means the difference between two date times is a time delta object. This time delta object can also be added to or subtracted from datetime objects to get new datetime objects. The strftime method returns a string representing date and time for the datetime object.
We know that there are many formats to write the date and time depending on your location. If you're in the US, you probably use month, day, year format, but if you're in the UK, you will generally use the day, month, year format. The strftime method allows us to display the date and time in a custom specific format. Let me show you what I mean. I'll go to my text editor and I'll say import datetime as dt. Now let me get the current date time. So I'll say dt.datetime.now. Let me print the current date time. So print current underscore date time. I'll save this file, go to my terminal and say python main.py. And as you can see, this is the current date and time during the time of this recording in the standard format. If I wanted to print the date in a different way, I could convert this datetime object to a date string in a specific format. Let me show you how. String underscore date equals current underscore datetime dot, because I want to call the strftime method, and inside this strftime method I'll pass an argument as %A, comma, %B space %D, comma, %Y. Let me print this string underscore date. I'll go to my terminal and say python main.py, and you can see Wednesday, comma, January 27, comma, 2021 is printed. This date is now in a much more human readable format. Here I'm taking the current underscore datetime object and calling the strftime method on it to get the string in the date format. Here %A represents the weekday name, that is Wednesday. Similarly, %B represents the month's full name, which is January. %D represents the day of the month, which is 27, since the time of this recording it's January 27. Similarly, %Y is the year, which is 2021. I could have also printed the date and time in a different format. Let me show you how that works. So I'll remove the terminal, and here let me change the format to something else. I'll say %B space %-D, comma, %I and %P. Now let me run this code. So here I'll say python main.py, and as you can see, I have printed the same date in a different format. Here, these are format codes that made it possible to transform our datetime object to a string in a certain format. There are many such format codes available for us to use. Don't worry, you don't need to memorize all these format codes. You can visit our article on strftime to search among all the formatting directives as per your needs. The link will be in the description below. The strptime method is the opposite of the strftime method. The strftime method converts datetime objects to strings, whereas the strptime method converts strings to datetime objects. Let me show you what I mean, and I'll say import datetime as dt, then I can say date underscore string equals, so let me pass in a date that looks like 21 June 2021, and then I can convert this to a date object by saying date underscore object equals dt.datetime.strptime, and the first argument is the date string. So here I'll say date underscore string. The second argument is, as before, the codes that represent the different parts of the date. So I can say %D because 21 is the number of the day, and then I can say %B, comma, similarly year in numeric format was %Y, and then end the quote, end the bracket. Now let me print what date object I get. So let me say print date object, and here I can say date underscore object. Let me go to my terminal, say python main.py, and as you can see, I got the date object that I was looking for. Here I have passed both the string and the format in which the date is represented in the string as parameters to the strptime method of the datetime class of the datetime module, and this gave me the datetime object. As I said before, %D represents the day of month. Similarly, %B represents the month's name in full, and %Y
represents the year. It's also important for me to leave this comma and space here because it's the format that my date is in. While using strptime, the string and the format code must match exactly. If the string and the format code don't match, we will get the value error exception. Now that we know about strptime and strftime, we can convert any date in any format to another. For example, if I have a date string in the UK format and need to convert it to the US format, I can first convert the UK date string to a datetime object using the strptime and then convert this object back to a string in US format using strftime. At this point, we have covered all the basics of using the datetime module except one important topic, handling time zones. Time zones can be especially tricky if you're working with them for the first time. For example, in Nepal, it's currently 6:05 p.m., which means it's 7:20 a.m. in New York and 5:50 in India. As this video is already long, we will not cover this topic in this video. If you want to learn how to handle time zone issues in Python, we suggest you to use the PyTZ module. It's the same module recommended by the official Python documentation. That's it for this video. If you want to revise these concepts, you can find all these programs in our GitHub repository. I'll also put this link in the video description. Python decorator is a function that takes in another function, adds some functionality to it, and then returns it. In this video, you will learn how to create decorators and why you should use them. Before we learn about decorators, we must first understand a few basic things in Python. We must be comfortable with the fact that everything in Python is an object, including classes as well as functions. Variables are simply identifiers bound to these objects. If you want to learn more, we already have a video on this topic. You can refer to that video. Since functions are also objects, we can also pass functions as arguments to other functions. Let me demonstrate this to you. I'll go to my code editor and here I'll say def inc x. So I'm defining a function that returns x plus 1 or whatever is passed in plus 1. Now I'll create another function which takes a function as an argument. So here I'll say def operate and func x. This will save result equals func x and then return the result. Here the operate function takes two arguments. The first is a function and the second is a regular argument x. Let me call operate with the inc function as the first argument. So here I'll say operate inc and I'll pass 3 as the parameter. Now let me print this. So here I'll say print, and when I press run, then you can see that 4 is printed. Here's how this code works. First, we have called the operate function with the inc function as the first argument and 3 as the second argument. This inc function is then assigned to the func parameter inside the operate function. Then we have called the func function and assigned the return value of this func to the result variable, and in the next line we have returned whatever result was stored in the result variable. In this case, since we have passed 3 and inc returns x plus 1 or 3 plus 1, this whole function returns 4 and that is what gets printed to the screen. The main takeaway from this example is that a function can take another function as an argument. In Python, we can also define a function inside a function. Let me show you an example. So here, let me remove this old code and here I'll say def print underscore message and then let me pass the message as the argument. Inside this function, I'll say greeting equals hello and then let me define another function inside. So here I'll say def printer. Now this does not need any arguments. And here I'll say print greeting and then the message. Now let me call printer from inside the print underscore msg function. So here I'll say printer and then from outside the function I can say print underscore msg Python is awesome. Here I have defined an inner printer function inside the scope of the print underscore msg function. Here's how this code works. First, we call the print underscore msg function with Python is awesome as the parameter. Inside the print underscore msg function, we have called the inner printer function which prints the greeting
and message variables. Now let me run this code, and you can see that hello, which was the value of the greeting variable, and Python is awesome, which was sent as the parameter to print underscore message, are both printed. The main takeaway from this example is that we can define a function inside another function. Another thing we need to understand about functions is that they can also return a function as a value. Now let me modify this code a bit. Instead of calling the printer function from inside the print underscore msg function, I will return the printer function itself. We already know that if there are parentheses after a function, that function gets called. In this case, I don't want to call the function but return the function itself. So let me remove these parentheses, and here I'll say return printer. Now I'll assign the return value to a variable named func. Now outside the print message function, here I can say func equals print underscore msg Python is awesome. And let me run the func function, so func and parenthesis. Let me run this code, and you can see I get the same output as before. But do you notice something weird here? We can see that the outer function print underscore msg is done executing on this line. This should mean that all its local scope variables are destroyed after it finishes executing. However, when we call the func function, we still have access to message and greeting variables in the inner printer function. Such a function is called a closure. A closure is simply an inner function that remembers the values and variables in its enclosing scope even if the outer function is done executing. Python decorators make extensive use of closures. Now we are finally ready to learn about Python decorators. A Python decorator is a function that takes in a function, adds some functionality to it, and returns the original function. Let's try to build a decorator function that prints out some information before and after executing another function. I'll go to my code editor and first define a normal function called printer. So let me remove this old code, and here I'll say def printer. This will just print hello world. Now I'll define a decorator function that takes in a function. So outside this I'll say def display underscore info, and then I'll pass func or function as an argument. Now I'll add an inner function that prints out some information before and after executing the function. So here I'll say def inner. Now I'll use the underscore underscore name or dunder name attribute of the function to access its name. So here I'll say print executing, and I can say func dot underscore underscore name underscore underscore, and then I can say function. Then I'll call this function. So here I'll say func, and after the function is executed, I can say finished executing. So here print finished execution. Now inside this outer display underscore info function, I'll return the inner function. So here I can say return inner. Now let me run the printer function normally first. So I'll go outside and I'll say printer. Let me run this, and you can see that hello world is printed, nothing fancy. Now here comes the magic. I'll use the decorator function to run the same printer function this time. Let me remove this code. Now I'll call the display info function with the printer function as the argument and store the returned value. So I can say decorated underscore func equals display underscore info, and this will take in the printer function as an argument. Now let me call this decorated underscore func function. So I'll say decorated underscore func with parentheses, and when I run this code, you can see that executing printer function and finished execution are printed before and after our hello world. Here's how this code works. When this line of code is executed, the display underscore info decorator function gets called with the printer function, which gets converted into the func argument. Inside this display underscore info function, there is an inner function. This inner function prints out executing the func name function, calls the func parameter or calls the function that is passed as a parameter, and then prints finished execution. As you can see, the decorator function acts as a wrapper. It allowed us to add some functionality to the past function without changing the code of the original function. In Python, we have a much more elegant way of writing these lines implicitly using the @ symbol. Let me show you how. I'll first remove these lines and rearrange these functions. So let me remove these. I'll copy this code and put this before printer. You will see why I am doing this soon. Now comes the magic. Instead of calling the display info function before the printer function, I'll say @display_info. This code is equivalent to our previous code. As we can see, adding the @ symbol on top of a function definition means that we are passing that function as an argument to the decorator function and reassigning the function to the return function. We passed the printer function to display_info decorator and reassigned the printer function to the returned inner function. As you can see, adding the @ symbol is a sweeter way to do the same thing. It also avoids creating one more extra variable. We pass the printer function to the display_info decorator. Using the @ symbol makes our code much more cleaner, and we can now call the printer function directly without assigning the decorated function to another variable. So in my code editor, I'll directly call the printer function this time. I can just say printer, and when I press run, then you can see that I got the same output as before while writing a lot lesser code and also making it much sweeter, or much more syntactically pleasing to see. The decorator we created in the previous section was simple and it only worked with functions that did not have any parameters. Now let's discuss how we can create decorators for functions with parameters. Suppose we have a simple divide function. So I'll go to my code editor, remove this old code and say def divide a comma b. So it's a function with two parameters and it says return a divided by b. At this point, we already know this code will throw an exception if we pass the value for b as 0. Now let's make a decorator function called smart_divide to prevent this. So on top of this function, I'll say def smart_divide. Now smart_divide will take a function as an argument. Since the inner function will replace our original function, the parameters should be added to the inner function. So here I'll say def inner a comma b. I'll print out some information before dividing. So here I'll say print dividing a by b. I will then check if b is 0, and if so, I'll print a message and use return to stop further execution. So here I can say if b equals 0, print cannot divide by 0, and then I can say return. Else I just return the function. So I'll say return func a comma b, and then on outside I can say return inner. Now let's add this decorator to our original function. So here you must have already guessed what I'm going to do now. I'll say @smart_divide. Now let me call the divide function. So here I'll say divide. First I'll call it with non-zero arguments and then I'll call it again with a 0 denominator. So divide 15 by 3. Let me put this in a variable. So I'll say value 1 equals divide 15 3, and let me print value 1. Similarly, value 2 equals divide, and this time I'll say divide 5 by 0. Let me put a space here, and here I'll say print value 2. Let me run this code. As you can see, in the first call, the denominator was a non-zero element, so the value after division is returned and it gets printed to the screen. In the second call, the division was halted and no value was returned. That is why none gets printed here. In Python, a function can be decorated multiple times with different or the same decorator. Let me show you what I mean. Here I have a simple printer function that prints whatever message is sent to it as a parameter. I also have two decorator functions, star and %. These functions print a series of star and percentage symbols before and after executing the function. Let's now decorate the printf function with the star and percent decorators and call the function. So here I'll say at percent, and similarly I can go to the next line and I can say star. And let me call this printf function, so I can say printer decorators are wonderful. Let me run this code. As you can see, these decorators are chained and they wrap the original function. Here we have first added the star decorator and then the percent decorator. So the star function wraps the percent function and the percent function wraps the printf function. At this point, we have covered the basics of Python decorators. If you want to learn more about decorators, you can check our article on our website programiz.com. The link will be in the video description.
If you're enjoying this video, please also check out Programiz PRO, where we provide tutorials along with quizzes and challenges which will help you practice and test your learning in real time. Also, the course includes projects to give you an awesome experience of how programming works in the real world. And for our YouTube subscribers, we are giving 50% off on the yearly plan. Sign up by scanning this QR code or use the link in the video description to claim your discount.